Jo, můžu mít prosbu šlo vypustit už ten obraz z počítače sem. Já tam
Good morning, everyone. Welcome aboard the XML Prague flight number 2017.12. All the issues are closed now. So we are going to have a 9-hour flight to the demo jam, and we will travel all this long among all the XML presentation over there. Hopefully there's no turbulence because there are no JSON presentation today, no RDF presentation, no CSV presentation either. So we have a bunch of sponsors to present. The external temperature is -4 degrees Celsius, so be ready if you go smoking. Please don't leave any things unattended during the breaks, and make sure your seatbelt is not fastened during the presentation, because you will have to ask questions. Please do not sleep during the presentation. It's very important for the speakers. Please also remember that there is coffee breaks. So in case of an emergency, just go over there and take some coffee and come back. So this is our opening for the XML Prague. So thank you very much for coming this year. Again, this year we have a big, huge number of people coming. We are more than 200 people. So more than, yeah. Thank you very much, everyone. More than 200, so it's even more than in 2012, so before the Brexit. No, nothing related. So, okay. So, I want to thank few sponsors today, and also to present you something. So I will first ask Norman Walsh, the guy who is tall enough so you can see him working, because he's going to present you something very important that happened tonight. That didn't happen last year. So.
Yes, well, I didn't have a passport last year. Long story. So I'm going to host Demo Jam this evening. I stand over here.
Hey!
If you aren't familiar with Demo Jam, I will give you a brief summary. You get a microphone and a projector and 5 minutes to present anything you would like to a crowd. How should I describe the crowd? Drunken rabble. No, that's not how I should describe the crowd. An enthusiastic crowd. There are no rules about what you can present. It's anything at all. The only rules are the maximum number of people is 10. I will not take 11. It's just too long. So at most 10 presentations, so get them in early. And you get 5 minutes. You get 300 seconds. You don't get 315 seconds. We cut you off promptly. The crowd will begin to chant 10, 9, 8, 7 at an appropriate moment. So keep it short. And if you want to participate, please, even if I know who you are, even if we've been friends for 20 years, write your name on a piece of paper and the title of your presentation and hand it to me at some point before this evening. I will put them all on a list. We will randomize the list before the presentations begin. So it's first come, first serve for the 10 slots, but you go in a random order. And I don't think there's anything else I need to say.
Something not allowed to do.
Your morals may have an impact, but I don't care what the demos are. Obviously, something technical, something XML related is good. Sometimes people ask me what's likely to win. Let's see, beer drinking won 1 year, singing a song won 1 year, a demo jam at another event, a young man won for juggling. So it's wide open. To be fair, some technical presentations have also won. So you aren't obligated to be entertaining, but and there is a prize, I believe, although
yes.
I don't know what it is.
The prize is a surprise also.
Prize is a surprise. So prepared to be surprised by the prize.
Yeah. Exactly. Thank you very much, Norm. So remember that you have to register quickly because there is only 10 slots. And as I said, more than 200 people over there. So thank you, Norm. So we have Norm today to do the demo jam because we have a bunch of sponsors that help us this year. And I will start by a very important sponsor. You will understand why it's important, because he's sponsoring the beer tonight.
Well, thank you for giving me the chance to sponsor the beer, because I like beer very much. I hope you do too. Okay, great. One thing I have more to say, just to say thank you for letting me sponsor this.
You can present speed data in 2 minutes.
Well, it's a very nice publishing system. we can produce automatic PDF, which are not only automatic but also beautiful. And in case you have missed the presentation yesterday, most of you have, you can just ask me later.
Beautiful PDF, remember that. So thank you. The next, yeah. Since there were a lot of people that were interested in sponsoring Beer Station this year, we have to split or to augment the volume of beer for this year. Let's see it that way. So Eleter also proposed to sponsor the Beer Station.
Yes, that's one part of the deal. I think we are now second place, so we asked, okay, if oxygen has to be first, let LETech be second. And we are very proud of it. And speaking of oxygen, you will see my talk tomorrow or listen to it. And George Bina personally implemented some minor tweak into the Oxygen, hopefully 19 product, in order to make it really compelling what I'm going to show you tomorrow. And this is such a good sign of XML Prague, of the spirit here. So sponsors, companies, mostly led by engineers or even PhDs, who are just here for the geek of it. So it's really an honor to be here and to be sponsoring this.
Thank you. What Gerrit didn't tell you is that they are also contributing to the sponsoring of the demo jam tonight, and is also the instigator of the surprise for the prize. So if you want to know what the prize is, you have to beat this guy. So next sponsor is one of very important sponsor here for this conference, because we saw this company growing from 1 people to 1,000 or something like that. Not quite 1,000. So, and it's Saxonica. So.
Thanks, Moz. We're very pleased to be sponsoring XML Prague this year. We're here in force, 4 of us, which is pretty well the entire technical team of the company. We hope you'll take the chance to meet us and ask us questions and tell us what you're doing. The reason we come here is to meet you and to find out what people are doing with our product, because it's one of the few chances we get apart from bug reports, and that gets a bit boring. But we're sponsoring the conference because it encourages the growth of the XML community, and that's what we thrive on. And let's enjoy ourselves and talk as much as we can during the 2 days. We want to know what you're doing, and if in the course of that we have to say a bit about what we're doing, then that's the price we pay.
Thank you. Thank you, Michael. Thank you. So I still have few information to give you before the first speaker can talk. Few informations for the newcomer, because I saw that there is few heads I never saw before, so maybe I was asleep last year. But anyway, so you have on your badge information about the Wi-Fi access, in case you didn't know. So it's written upside down. That's a new trick. I didn't know how to do that, but it seems like PDF is improving. So anyway, so you have so it's on the conference. We had 200 people, so you're allowed to download anything except doing development with Maven or any other things that download all the internet on your computer before starting a simple Hello World application, okay? So please do any kind of videos, whatever, but not development. Thank you very much. So that's one thing. The second thing is that tonight it will be at the same place as last year. We will say that again during the day. But just in case you have to leave during the day, which may happen. And there will be a dinner and demo jam. So if you have a full pass, you just go there, no problem. And follow the crowd. If there is any question, you can ask us during the breaks. We can give you information. Over there is place for sponsors where they can give you away things during the breaks over there. And as I said before, very important is the coffee over there. So, and during the breaks, there will be 2 places where you can have food, but coffee is only above, just in case. So I think that's about it. Yes, very important when you come back from the breaks, don't bring coffee in the room. It's the only, you cannot smoke in the rooms and you cannot bring food in the room, but you can do XML, so shit happens, you know. So anyway, so I will start with George. George Bina is going to do a small presentation of 20 minutes, 40 minutes, I don't remember exactly, about the new XML Authoring as a service, so XAAS or something like that.
Good morning. I'm really happy to be again at XML Prague. And I would like to, last year I had some pictures showing the history of XML Prague. Now I hope I will give you some ideas of what we can do with XML. So my talk is titled XML Authoring as a Service, and I was thinking about XAAAS, but yeah, it's too long. And last night I was with Young, and he said at the table, he said you should use XAS, as a term. Maybe, I don't know, this will catch up, I don't know. We'll see. But I think we use a lot of services for different things these days. For storage, for versioning, we may use, for instance, GitHub. For publishing, for running scripts to integrate different things. We can use continuous integration servers. To communicate, we use also services like Slack, for instance, for project communication and so on. So what if we add XML authoring as one of these services? Because these services are, I think I'm too loud. Okay. These services are actually connected to realize different solutions or workflows. But I don't like to speak, to follow all the slides. So I will switch to something to show you exactly what I mean. So this is the xprog.org website, which is actually maintained by Norm. And of course, Norm will maintain this in Dogbook, most likely, rather than in other formats. So basically, you see the source of this page is on GitHub. It's this index.xml, which is a Dogbook file. It was an workshop just before XML Prague. It may be nice to have some information available on this page, right? To mention, I don't know, something like latest events or something like that. So what do you do to provide, to make that change? Right. So you have to, I don't know, maybe fork the project, clone that, find a topic, edit that, commit, push, send a pull request, and maybe Norm will accept it. But it's quite a long way. So if we will have a service, and then just point to a URL that represents this document to interact with that document, maybe things will be easier, right? So what happens is that there is an edit page, an edit link here, and if I push this, basically an XML authoring service is invoked with exactly that source document. So now let's say I want to add a new section. So let's say we add something like on February 7, 8, there was a workshop in Prague just before XML Prague, and I save this. Now, of course, I do not have access, commit rights to norm repository, so I'm asked to send a pull request if I want to send a pull request. I accept that, and norm should have a pull request with my change. Right, so so basically now if norm will accept my pull request, or he may comment that I need to put a link maybe for XML Prague, and then I can come back and mark that up as XML Prague with the link to the conference website and so on. And then he will accept the change maybe, or maybe he can accept it right away and we will see it available on the XProCore website. I don't know. But the idea is having XML authoring as a service allows this experience where rather than using, something like this is the usual GitHub workflow that I mentioned earlier with so many steps, with the fork, clone, check out the working copy, the specific branch that you want, edit, find and edit the file, commit, push, and send a pull request. So all that can be replaced with something as easy as click to edit, change, save to send a pull request. So to get an idea what's going on, usually you have, in this case, we have, for instance, GitHub. GitHub Pages is usually used for publishing, and Travis, you can build from the XML source and push the generated content, let's say, on a branch that is visible through GitHub Pages, which is the publishing service. And Oxygen XML Web Author is used as an XML authoring service. So this is another example that I have in this diagram with the Data Open Toolkit documentation. So in this case, we had a dogbook. Here we have the Data Open Toolkit documentation, and basically if you browse the documentation and you go to a specific to any topic. Here you also have edit this page link, which brings that content into the authoring service, and you can interact with that. Here you can see, for instance, something about the editing context. In this case, for data, you have also the map as the context for editing. I have also a project on GitHub called GitHub data-wiki, GHD-wiki, which basically tries to, so it does automatic publishing, provides a history link, for instance, so that will go to GitHub, so you can see all the commits. So you can also see the changes made to a file. And also on edit, which brings, again, that topic into the authoring service. Here, the idea is that the user interface this is lightweight data, and for the user interface, you have, a customized user experience, a customized authoring experience with actions and so on. To edit a link, for instance, you can just edit that in line, just pressing an edit button next to that. So rather than going to access attributes on a side view, you can edit them directly in the user interface. I just want to share two other use cases that we find useful. I've been to a number of conferences where they were talking about how can we enable a feedback from our support team to the documentation team, because in many cases they are disconnected. Let's say someone writes on your support channel and reports an issue. The support team may look into the documentation to find if there's an answer to that problem. And at that moment, they can see if what they found actually responds to the specific question, to a real question, or not. They may find that the documentation has some bugs, maybe something is not correct, or something is missing. In order to send that feedback to the documentation team, what can they do? Write an email, maybe open an issue, and sometimes that will be fixed. So what we try to do for our own documentation is that, let's say can you give me a search term? I don't know, something that you do with Oxygen, schematron, or what do you do? JSON, I don't know. So editing JSON documents, for instance, right? So let's say if I go to this topic and I see that there is a problem that I want to correct here, as a support engineer, rather than opening an issue or doing all kinds of things, I can just edit the topic. And as you've seen in the case with the XMLPrague, I can provide a suggestion for the documentation team, basically. So they can then, accept that or reword what I suggested, but they still get that immediately. And it's a direct link from the support team to the documentation team. And the last use case that I wanted to share is that we are a software company, and let's say a developer will work to fix an issue, to create a new functionality in Oxygen. when that is documented by the documentation team, we want exactly that developer to review that documentation, because from a technical point of view, because he knew exactly what he implemented. So how do you bridge, how do you link them? Our developers use Jira for issue tracking. So what we've done is that when the technical team will change something on the documentation that's related to a specific issue, automatically we will inject in Jira a message that allows them just to click to open that file. Here you have, such an example that allows the developer that has that issue assigned to have a link directly in that issue, and he can just click on that link to see the changes made to the documentation. So the power of, let's say, web-based XML authoring is not in the fact that I have something in the browser and I go and open from there, right? Go browse and find my files like I will do it in a desktop editor. The power of XML authoring stays in this seamless integration into a workflow. And I think we need to see this as not as a browser-based editor, but as a service, as an XML authoring service. So my takeaways will be, maybe we can start using this term SaaS, XML Authoring as a Service. And I think it is possible now to have different systems that we thought about at some point, like a structured blogging system or based on dogbook or based on data or something like that. It's possible. It's very easy for people to interact with XML content. Just click, make changes, save. Behind that, you can hide or the complexity of accessing the file, committing, or whatever can be hidden from the user. And with a customized authoring experience, as in the case with lightweight data, the interaction with the user does not need to know about the underlying XML structure. And I was trying to push also the guys from Delta XML to create a diff service. I asked them a few times, because that will be also useful to have an XML diff as a service, to have a number of XML publishing processors, let's say, available as a service as well. So then we can very easily link them to create a custom or a specific solution. Let me see if we have anything here.
Travis is having some issues, so it's not succeeding in the build. If you go to the repo, you can see this in there, but Travis is confused.
So at some point, probably we'll have the Xpro code updated with my suggestion. But I was thinking also along the lines having Saxon.js maybe together with a raw XML document, so you don't need Travis basically or anything to publish that. So thank you, and I hope I gave you some ideas of what you can do. Thank you.
We have time for one or two questions. Waiting for John Lumley to set up his computer for the next talk. So, any questions targeted to George. Oh, sorry. I'm not seeing very well.
Probably don't need a microphone, but perhaps the recording would prefer I had it. Yeah. George, thank you very much. It's kind of cool stuff. I want to poke two questions. Remind me, Oxygen web authoring does permit me to show angle brackets, right? Because I don't know how to edit without angle brackets.
You can display tags.
Oh, good.
And it has also source editing mode.
And then I wanted to poke at you a little bit about the name of this product. At the moment, you don't have the capability to allow multiple users to edit the same document simultaneously. So either you are withholding the obvious name, Oxydoc, for that service, or you're going to name this Oxydoc.
So we do not have concurrent editing on the same document. We have some ideas of how we can implement that, or some degree of concurrent editing. But depending on the repository, you can have automatic locking. So when when one user is accessing a file, that will be read-only for the others. And that kind of solves, let's say, this. Okay, thank you.
Thank you, George. So I proposed the name on Twitter of Xasonica, very difficult to pronounce, but maybe it gives an idea to the people from the next presentation. So Saxonica via John Lumley.
Is that one still on? Can you hear me? Yes, you can hear me. That's one.
Okay. Yes. Try.
Yeah.
Yes.
Bring it up. A bit higher. Yeah, that's fine. That seems to. No, it's fine.
Maybe.
It was possible to hear you. Just attach it and give some time to technicians to adjust the volume. It should be fine.
It's like a laser beam, right?
Right. Okay. Right. You can hear me now. Okay.
So next talk is about XPath in the browser. So it's in the long series of X something in the browser. We have had XQuery, XSLT, and any other X thing in the browser. So now it's about, I think, the last edition of XPath in the browser. Thank you, John.
I'm going to talk today about That's not my fault. All right, that sounds a bit better. Okay. A simple execution plan for an XPath need to do.
We'll try to start during your talking.
Okay. It's dependent on where I'm standing with respect to. You want to use different mic? Okay. Sorry about this. Right, let's switch it. It's just got to go over my head. Okay. Okay, fine. Right. Can you hear me? Can you hear me now? Yep. Okay, that's better. Right, off we go. I'm going to talk about the context. I'm going to talk about parsing the XPath, and then the whole issue of converting that to Saxon.js instructions. Then I'm going to talk about the development methodology, the testing and the results, and you're going to see some demonstrations, and I'll draw some conclusions. It is terrifying to think that XPath is nearly 20 years old. There's nobody in this room who wasn't born then, but large numbers wouldn't have started coding. We saw in 1999 an XPath1 from the merger from XSL and XPointer. And in those halcyon days, the developers of browsers put that in XSLT1 into the browser. However, as we all know, that's being killed off by those idiots who wanted to do things like look at Facebook or Twitter on mobile phones. So in recent times, because that feature has been dropping from some of the browsers, a number of people looked at JavaScript native implementations. Right. The XPath, the X family that was going to end up in the client, fled that habitat to the much more gemütlich lands of server-side. And we then carried on working over the next 8 years and 8 years on increasing the standards to get to an XSLT2 and XQuery level with XPath 2.0 in 2007. And again, people have done some JavaScript native work on that. Of some particular note, Mike Kay, Phil Fearon, and O'Neill Delprat in 2011 worked on a cross-compilation of the cut-down Saxon to produce, using Google technology to produce a JavaScript compiler and run. And that became Saxon CE. A number of you have used it. We used to use it in Saxonica for the documentation, the website. It was really tour de force, but it required an enormous amount of tending to keep it going. It was extremely dependent upon the development tools, which were completely outside our control. And eventually, it was put out to open source pastures. At the same time, we moved on into XPath 3, and and Mike will tell you more about all that situation tomorrow. And last year, or around last Christmas, he started working on some stuff, which then Debbie Lockett's been working on him with, which we call Saxon.js. And Saxon.js went to its 1.0 release on Tuesday, or was it Wednesday? Tuesday it was. And that takes a different approach. It does a server-side, or effectively server-side, compile of an XSLT in Saxon, using Saxon EE, and then it has a JavaScript client-based, or JavaScript execution engine that runs in the client. And that basically, that's the thing that we're based on, this work's based on. Now, this isn't a talk about Saxon.js, but you can talk to myself or Mike or Debbie or O'Neill. We'd be very happy to see what you're using it for. But you need to know something about how it works. Normally, you take an XSLT3, you put it into Saxon, whether you've got a licensed product or an open source, or you're sitting in Oxygen, and it creates a transform, and you take XML in to produce XML out. However, Saxon EE can also be used to produce a stylesheet export file, an SEF. It's an execution plan that's written in XML, and it's the execution plan of effectively the final end stage of a Saxon PEE level of optimization. So it's had all its type checking, everything is done in that place. And then you can take a browser and you can take a web page which loads in a thing called Saxon.js, which is JavaScript. It's about 220 kilobytes minimized. And you can then execute Saxon.js.transform with a number of arguments, one of which points to that stylesheet export file. And it then effectively interprets the instructions that it finds, which includes things like templates and sets of templates, sequence generators, all sorts of things. And then you get, effectively XSLT3 in the browser. And it actually has the same interactive features that were if it were developed originally for Saxon CE. So you have interactive Saxon 3. At very high levels of conformance indeed. There are some things it doesn't do, and I'll explain that in a second. Oh, and one thing I really should emphasize. Saxon.js is an execution engine for SEF instructions, and it does nothing else. So you're on your own, and that becomes important. Let's have a look a little bit of what the stylesheet export file looks like. This is effectively a tiny little bit of XPath. It's actually a repeater watch. It goes bong for every hour and ding for every quarter. And it's written as a set of a let with 3 variables defined. And the SEF for that is effectively a piece of XML. It's actually a tree, which we represent as XML, and obviously, of course. And we've done various things here. We've canonicalized the lets are now all nested. And in fact, it's effective in a set of nested functions, equivalent to operators. We've done things like allocate variable slots. We've also done some type determination to determine that the arithmetic has to happen in the integer space rather than something else. And this is the sequence generator for that, with a function call. An if statement has been canonicalized into a choose, so we only have one choose in there. And we've done some other stuff on type-inferred casting. Now, the features of Saxon.js is it handles a very large amount of XSLT3, and it certainly handles the new XDM types of map and array and JSON, and a large portion of the population of the 3.1 functions and operator set. In fact, surprisingly, you find, oh, actually it does that one. Okay. But it does have its limitations. It doesn't do streaming. Life's complicated enough as it is. And anybody wants to try doing streaming in the browser, you're welcome to it. It doesn't do packaging, because in one sense, packaging is a compile time operation, and you can use Saxon.js to package the pieces together. And in fact, the stylesheet export file was originally developed and is used as the means for link editing packages together in Saxon space. It doesn't have an accumulators. And for the particular purposes of this talk, it doesn't or didn't implement the XSL evaluate instruction, because let me emphasize again, in Saxon.js, there is no XPath compiler, and there's no XPath parser even. Okay. But, and this is not a limitation, but it's an absolute requirement. Saxon.js is small and fast because it requires the execution plan to be very correct. It is not going to check function argumentarities or their types. It is not going to it's not going to do the same for almost all operators. It is assuming that things like when there's a cast required for most things, a cast instruction has been generated to the appropriate piece, or a dynamic type check instruction has been put in place. And if you don't have that, it will run wrong. And the worst thing that we Saxonic can never have is something that runs wrong. It's far worse than running slow. Okay, so what I'm trying to do is to take a main process where I've got an XPath expression. I'm going to parse it and reduce it to a minimal XPath tree. I'm then going to take that minimal XPath tree and add some static context, namespace bindings, parameters that are already loaded, effective, or available, and compile it into a stylesheet export file. I'm doing this in the browser. It isn't actually a file in this particular case. It's just an in-memory data structure, actually a DOM tree at the moment. And then we pass that one with some dynamic context, what the context item is, and the actual bindings of the variable values put in the appropriate slots. And we get some results out. In this case, we get a result sequence. Now, this piece here is Saxon.js, and that's fine. It just works as it normally does. This part up here, is Saxon.js XPath. It's 166 kilobytes minimized, which means there's the same sort of order of size as Saxon.js itself. It's actually dynamically loaded. If you ask for any of the evaluation things, the first time it will actually pull it in from the library from where the Saxon.js came from. So it doesn't cause you anything if you're not going to use it, and it only loads up once. And that's what I'm talking about here. Right. In Saxon, normally the XPath parser is actually built in. It's a specific one that's been written. It actually does certain forms of change as that goes on. In this particular case, we could have rewritten, but we actually chose to use the EBNF and Günter Rademacher's excellent parser generator, which we use quite a lot, to produce a parse JavaScript, which uses a number of callbacks in terms of starting and ending terminals and things like that. And we use those at the moment to generate an XML parse tree of all the productions of this particular piece. And of course, if it doesn't meet the grammar, it'll error out, and we'll have an error in this particular case. The problem is that these trees are very deep, and this is something that Steve Pemberton's talked about in Invisible XML, and he may talk about tomorrow again, I think. But only a fraction of this is really of semantic importance. So what we do is reduce the tree. We basically take this tree and bring it down to here. This tree is probably more than 27 levels deep, actually. And the sort of things we do is we take tokens that effectively are parameters of an operation, like the star says it's a multiply rather than a divide, thrown into attributes. We do the important one of single child reduction. If you've got an element which only has one child, the default case is to punch through and just keep on reducing below you. We remove redundant tokens, and we also do canonical nesting. So that let, for example, would be a single let with 3 let bindings. We actually take it, so it's a binary tree of nested lets, which means the next stages are all dealing with canonical forms. They never have to check. They always know that they've got a binary pair to deal with, or whatever it happens to be. Now we've got this tree, we get to the hard work, which is to generate the execution plan. We have some term with 2 operands, and we have some static context. What are the bindings on variables? What are the namespace prefixes that are appropriate? And the big thing is a clash between the argument types that come up from underneath and the required type that comes from below. And if we take, for example, this case, suppose this operation here was salary minus 1,000. Well, salary in XPath is actually a node element lookup, short form, and the right-hand side is an integer. But the operator is effectively an arithmetic one working in the integer space. Actually, it assumes numeric. Okay. So what happens here is that implicitly you have to put an atomization operation in. In fact, it's a little bit more than that. You actually have to do a cardinality check and everything else dynamically on. And that's got to be done. Similarly, we've got things where the context type is important as to whether or not there's an error that's coming on here. And some operations, like the for each, the left-hand tree builds pieces of type which go down the right, become the context tree for the right-hand side. So in that particular case, we might have some rather more complex piece here. Or in fact, we might find that actually there's an error. And then once we've done that, we've got effectively that instruction tree. It has its type, and recursively it just goes on. Now, what I've done, I wrote this it's about whole thing is about 6,000 lines of JavaScript. This part's about 3,500. It's actually 22 major classes of different pieces. I could have possibly done it as objects things, but I think I learned a lot more doing it this particular way. Now, and this is an example of it. This is where we're basically taking the range expression and making a to instruction. Most of the Saxon JS instructions are in reasonable one-to-one correspondence with one of the productions in the XPath space. A large number of them are, actually. So what we're going to do is make we're going to make an element 2. We're going to recursively process the left-hand and the right-hand sides. We're going to then form up some diagnostic information, which we'll use if we need to write runtime diagnostic information. We're then going to add a child, which is the result of this most important thing, the type check. Because what we're saying here is the left-hand side is required to have a type of optional integer. And I'll talk more about that in a second. And we do the same for the right-hand side. And then we've finished that, we've got a set type, because we know the type of this node is actually an integer sequence. So that goes back up into the recursive space. That's fine. Okay, this type check has a number of different requirements. Well, first of all, it's a critical component. In fact, if you looked at something like Saxon G, this particular piece is probably one of the 3 or 4 most critical components in the whole thing. If this goes wrong, you start getting wrong results wholesale. It's required to, first of all, detect semantic type errors where this cannot possibly work, or this can work if there's a cast which is possible across this piece, or this could work provided this runtime thing is in the following sort of cast, in which case we put type checking instructions. And the way I wrote this one, originally I started writing it by hand, and then I got a bit further and then looked, and then took the Java class type checker and transcribed it into JavaScript. And actually, a lot of it looks absolutely identical. Lots of the it's a good thing that they both have semicolon as the statement separator. Oh, so they use that, and with a lot of operators, we know what function, what type we need for the operands. But we also need to deal with functions. And function call is in Saxon.js is basically a function call instruction whose parameter is the name of the function, and whose children are the arguments of that function. So in order to type check this, we actually require the function catalog. So we generate it from the W3C spec as a signatures, arity, etc. And we use that as part of our process to check that the calls are correct, the arity is right, and they're necessarily, the types are either fail, or they've got a cast, or they're correct, or whatever it happens to be. And you want to stress this again. You put the wrong number of arguments in here, 2 men. Saxon.js is not going to try and check that. It's just going to go. It'll probably, if you haven't got an argument supposed to be there, it'll assume it's null, probably might be considered to be the empty sequence, but it's all part of making Saxon.js lightweight and fast. Okay. Some things that in the XPath space that look like function calls actually, in one sense, aren't. They're type constructors, and we convert those to cast instructions. And there are some others where there is some implicit casting, particularly where there's a default argument. So, for example, the string length without any argument actually requires string length of a stringification of the context item. Variables, very similar system. They're either invocation parameters for the expression, or they're the subject of a let. We add them to the static context definition. We allocate slots for them. We infer their type by looking at their generator tree. And then our scope is the normal scope, and the tree scope, it all works quite nicely. And they interpolate through varref, and we can do type and slot reference from there. Now, how do you develop such stuff? So I have an XPath expression 1 to 10. I've parsed it, and I look at what that parse is, and one of the systems you'll see in a second is we can see all these trees and serialize them out as being extremely important, and then we can compile it to the SEF, and we can probably run it and see whether it works. But actually, in developing it, I need to know what these things look like. So we could appeal to the Oracle, but it's not really fair to keep asking Mike every 3 or 4 minutes about something. So we use something he prepared earlier. We use XSLT3. We load that XPath expression into a minimal one, push it through Saxon EE, and look what SEF produced. So that gives us a hint about what these things mean and how they're doing, and it's actually a very nice way of doing things. A few other things we actually specifically put determined types on these trees, so we can check that sort of thing as well. And that's what we did. Okay, and I still use that to this day occasionally to go back and look, what did Saxon EE make of this one? What the hell's that thing? You know, why those flags mean and that sort of stuff. And then I go back and look at the Java to try and find out what's going on. Okay, but that's not adequate to test this system. You can do it, you can produce test bits and pieces, that's fine. But to get it XPath, you've got to test it. Our forefathers before us basically spent a lot of time putting together up to 30,000 tests for XPath in the Qt3 test suite, which is the catalog, is a bit of XML, and it produces a whole lot of tests. It has a lot of tests. Here's a simple one, which is effectively checking that if you do concatenate in the presence of arithmetic bits and pieces, it's going to do it string concatenate, it's going to do it correctly. So we could, normally in Saxon, we have a Java test harness to deal with this one, but we can produce a piece of XSLT which reads all that in, takes the test, and passes the XPath to an evaluate instruction, evaluate it, get the result, and then check the assertions that we've got. And we could normally run that as a piece of just straight XSLT, but we can also compile it to an SEF, and then we can link that to a web page and run the entirety of the Qt3 test suite in the browser itself. Okay. And that's what we've done. And there are classes that we don't deal with, there are features that we don't support and that sort of stuff. There are about 18,500 we actually run. And for Chrome, we can do that. We get currently there's about 115 failures. There are 173 that fail but get the wrong error. And it takes about just under 3 minutes on this laptop, which is pretty good performance, actually, in comparison with what we do when we just run under normal Java operations. So I'm going to show you what that looks like. This is it. Okay, here's Chrome. I'm going to load up my, I'm just running it off a local server. This is at the top, is some examples. Here's a case where we've got, let me make the thing a bit bigger. Okay, this is a piece where we've got an XPath, and that was the result of evaluating it. This is another example where I've got the XPath age plus 22, and this is what I compiled it to in terms of the instructions, and we checked that against what Saxon would do. But let me go back. Oh, I don't want to go that way. So now we have effectively read in all the Qt3 tests. It's already been done now. We've got some accepted features, but we've got a whole string of categories. So I'm going to choose the mathematics categories. It's now loaded in. There are 149 tests in a number of categories there. Math, cause, sign, that sort of thing. So I'm going to select them all, and I'm going to say go. And it's now finished and run them all. And it's shown me that 144, and there are 3 errors. And let me show you what the errors looks like. They're all on mathlog10. And they basically, the errors are, the mathlog10 of 1,000 has come back as 2.999999996, and it's expected to be equal to 3.0. So we've got those sort of little precision things, but it shows them and they're all done. And just to give you an idea that it does work reasonably well, I'm going to clear this down. I'll give it time, I think. I'm going to load up the operator set. Right, we've got 4,000 tests here, and it takes about 30 seconds. And this has become really quite important. It's the one way I test the compiler that I'm doing, but it's also actually the only way we've probably got of really finding out inside the browser, fully in the browser situation, some of the real corner cases on Saxon.js runtime itself. We found things that were different on different browsers, which we weren't showing up on the Nashorn tests. So we've now finished these. That took what, 30 seconds? 25, fine. So it's we got 4 errors. One error that I'll show you one down here. Where are we? Here we are. There we are. Name equals, and it basically said that the name Q name equals to any URI failed, and it was expecting an error case. This is a case where my type checking hasn't worked properly. I'm allowing it to try and do a comparison that it shouldn't be allowed to do. That's it. Right. Now, let's go back. Okay. So that's the testing there. However, and if we go on, all I did was load up the browser, and that was Chrome. I actually normally work in Firefox. So if I want to try it in a different browser, I just literally fire it up with a different browser. And we can do it on all 6. I haven't tried Vivaldi yet, but okay. Right, if we then take each of these pages and we save the page as HTML, and in one case, in Safari case, it comes as a web archive, but we still know how to find the information inside that web archive. And then we write a piece of XSLT that looks and pulls all those in and agglomerates, then we can produce an agglomerated result across the entire set of browsers about which tests pass and fail under what sort of circumstances. And that's exactly what we've got here. This is effectively our browser comparison that I did on Monday. And here are effectively the pass and fail results that we had from the different browsers, and they actually change a little. We also get reports of what was accepted, what test cases were accepted similarly. And we also have a very specific thing we can look at which test failed and under which browser, under what sort of conditions. And it's really fascinating. There are, of these 18,000 tests or so, there are only 104 that every browser failed, and about another 100 that some of the browsers failed on. And it's become very interesting to try to work out, why is this one working on that one, but not this one? And you can see things that come from the original genesis of the different browser families, but some of them are a little weird, and we have to go on to that one. But I should say, a lot of these errors are right at the extremes of some of the XPath or cases. Right. Okay. Now, what I've been talking about so far has all been concerned with XPath in XSL evaluate circumstances. But I've put together all the information that's necessary for an evaluation outside of XSLT. And so we have a pure JavaScript API, and this is a bit which is trying to, as part of setting some clocks. It's a demonstration which is available on the Saxonic website. And this is a piece which basically is executing an XPath to find every element of this doc which is in class clock. And then for each of it, it's going to execute a set clock operation. And this is what it looks like, and I'll show you it running. Oh, sorry. That's it. Right, this is going to run it up. Okay, and it's now started running. And we've got some clocks here that are digital in HTML, XHTML, some clocks which are analog in SVG, and some clocks that are analog and digital in SVG. And the whole thing is written in terms of finding out classified pieces, class-classified pieces of time indicators, and working. If you're basically a piece of SVG and you're not a piece of text, then we rotate you by the appropriate angle. But if you are a piece of text, then your text content gets replaced. And that's all being, you can see that information. I can show you if you want to later. And it's about, well, actually, why not show you now? This is that's all the set clock. It's got basically three pieces of XPath that are being evaluated. And it's quite nice to see that we put this up and announced it effectively on Tuesday, and by Wednesday morning, somebody had already pointed out that our date system wasn't being converted backwards and forwards correctly. So it's nice to see. I'd reiterate what Mike said earlier. We would love to, myself or Mike or Debbie's sitting over there, or O'Neill, we'd love to hear much more about what any of you are using Saxon.js, because we'd like to find out more about it. Okay. Okay, the future. Well, apart from spending most of the next year squashing bugs left, right, and center, actually, hopefully not too many, but we'll get there. We could do some optimization. One of the things that I would need to think about, this parse tree reduction exercise is something we need to do. It's probably best if we can do something smarter in the callbacks. There's no point in building up a huge DOM tree to then make a small DOM tree by looking at it, if you can avoid doing that to start with. So that's one thing. We've got all the stuff about constant sub-expression evaluation, the sort of thing that Saxon itself does falling off a log. It's not done falling off a log here. And actually, unless you're going to do repeated stuff, it's probably not worth it. You probably may spend more time trying to work out whether you can do it than by doing it itself. However, if you're doing it for repeated stuff, it's possible to think about splitting the compile and eval stage, which we could do in JS API. It actually has a problem. The problem is that, remember this thing about the execution plan must be correct. If you start splitting those things and people putting in their own execution plans, it's going to cause possibly some problems. The paper on Saxon JS that Debbie Lockett and Mike last year in Balisage suggested a possibility that we might think about a JSON format for SEF. If that happened, then we could do the same thing inside the XPath. It wouldn't be a problem. I originally wrote this compiler all in JavaScript. Mike had suggested one stage, why not do some of it in XSLT, but I'm glad I've stuck doing this because I've learned a lot more. However, there is an argument for doing it in XSLT in terms of, well, maybe simpler to read and see, but it will also support the possibilities of retargeting to another runtime environment, rather runtime language if we ever got to that sort of stage. And in grey here, because it's a really murky area, we've done a lot of the hard work, I wouldn't say all the hard work, a lot of the hard work of doing simple XSLT inside here. We've got to do a bit more for things like pattern matching and that sort of stuff, but we've got a lot of the type checking in. So it's possible to think and consider doing function transform support in the browser, though whether it be anywhere near the levels of conformance we've got is another matter. So the conclusion of this talk, if you have an instruction execution engine, then you can do in-browser XPath evaluation. But there are 4 things you really must have. You must have an efficient and accurate XPath parser. Early stuff that I did in various times using regular expressions can work for just the right sort of simple thing, but it doesn't take very much before that breaks wholesale. The first time is when somebody gives you a string with $1 in it, that sort of stuff. You must have very accurate type checking code. If you haven't got that, it's going to be really problematic. Well, you're going to get wrong answers. That's the simplest way of putting it. You really should have an oracle to show you what the correct execution plans are, or it's very helpful. And you, in this particular case, you really need to get a test harness going in browser fairly soon. It means that you can start to run lots and lots and lots of things and then find those, that doesn't work in this particular case. And in conclusion, we have shown some very high conformance levels for this and rapid execution speeds. It's available on our website. You can try it out, and you can probably submit bug reports to us, but we're not going to do anything on them until next week. Thank you.
Thank you. Very interesting presentation. So I hope we have a few questions. I saw some remarks during the presentation on Twitter.
So could you just sketch why there are the differences between the different browsers in the number of successes and failures?
Recently, they had different, some of the reasons that we've fixed so far. A good example is file not found, parse error on an XML when you're reading a document. Okay? They all have different ways of doing it. They all have different results. So you actually then have to make sure your code can look at which different ways you want. You know, some of them will actually throw an error, okay, which is really what you want. Others will helpfully return you a piece of XML which tells you where it was. So you now have to go and look to find out, is it one of those pieces? In which case my document. It's that sort of little bit and piece that we have to deal with. And we'll start tracking them down a little bit more. There's one that fascinates me, is why there are two of them have 20. All right, there's a set of errors which are tests which work with excess float. And why anybody would want to use excess float these days, I have no idea, but never mind. And the excess in our system, there's float, is shifted into Java double. So you get tests which are more precise than they should be. And we get failures, and we don't consider those to be proper failures. They're just, you know, precision errors. Unfortunately, 4 of them have 49 of these failures, and 2 of them, but not the same family, Safari and one of the other, have 21. And I've still got to go and look at that in more detail. So the answer is, we'll nail these down a little bit closer.
Okay. Any other question? Okay. I think you answered one question I had in the beginning, was why you didn't do it in XSLT, but you answered it in the end. Will you,
yeah, it's the XSLT actually will not be as fast.
Yeah.
Because what you're going to do is you're going to produce a style sheet export file of the XSLT that you are then going to run interpreted in order to interpret one tree and make another tree, which is going to be an SEF that's going to be put in there. And so you can picture the sort of picture in your head. Probably, I suspect, it'll be about maybe a factor of 3 or 4 slower. That would be an off the top of my head in terms of that thing. As far as the speed is concerned, you've seen how long those tests took. It looks like each of those tests on this machine takes of the order of between 2 and 5 milliseconds. That sort of order. So for normal interactive type stuff, you're probably all right. If you're going to be in very tight loop type animation situations, then that's a different matter. But even in that particular case, that's a particular case where you're not likely to be dealing with you're likely to be dealing with the same XPath being repeatedly used. So you could actually think about compile once and run many times.
I have a last question. If there is no question.
There's one.
Oh, there is one. Okay.
Well, I may be wrong, but it seems to me that you are very close to doing an X-forms evaluation. Am I right? Because it would be interesting.
It's possible. I mean, it's not something... I touched X-forms in some work about... where are we now? About 8 or 9 years ago, but I haven't touched it since. So it's something, if anybody's interested in discussing that and looking at it, then get in contact. And if they've got... You know, what we'd like, the sort of thing that we love is to see a small test case that would allow us to look at something like that.
Thank you. Last question. Why don't you test Node.js? Node.js?
Because I stay in the browser. That's Debbie's...
okay. Thank you. Thank you very much. So now is the coffee break, so you can have food at the first level or coffee with the sponsor information just over there. So see you in a few minutes.
Martine, neodnes jsi ten mikrofon? Neodnes.
Mohammed? I'm looking for Mohammed because Mohammed, probably you got mic in your pocket. So please bring it back to the desk.
Dobrý, to je dobrý, tohle. 1, 2. Musíme počkat, nemůžeme najít ten mikrofon, ten, co pískal. Má ho Mohamed.
Mám zkušenost, že tady to je lepší mít hodně blízko u krku, že jinak se to musí dát. No, či když se to dá hodně nahlas, že to je daleko, tak pak... pak to stačí hrozně rychle. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4, 5. No, trošku to vazbí.
Ale chytá to vazbu.
Trošku jo. A teď je to asi... Teď je to lepší, ale je to potichu možná moc, nebo je to slyšet? Can you hear me? A trošku to chytá tu vazbu, no. Okay.
Ty to máš co nejvíc, jo? Pak už to chytalo. Zkus táhnout přilo.
Yeah, we finally found it.
Sorry.
Yeah. Ale nemáte nějaký jiný ten...
Já zkusím, jo, ale on má hodně sensitivity. Takže já to zkusím.
Jedna, dva, tři, čtyři, pět. Co to, Janku, co to snět? Teď jsem vypnutej. 1, 2, 3, 1, 2, 3, 1, 2, 3. Víc neumím.
Dobrý, tak aby jsme vás nezdržovali, tak vy to dejte.
Jo, no, tak já vám to dám.
No, 1, 2, 1, 2. Hele, já jsem ubral trošku tvý senzitivy. Ty to máš teď na hlavu.
Kabelem to do zeleného a zjistíme, jestli to bylo kabelem. Víš co myslím? Zelený vytáhneme. Zkusíme tohle Ačko. To, co nám přinesli, co jsme tady nikdy neměli.
Počkej, tak chceš to dolů teda dát?
Dát.
Jedna, dvě, tři, čtyři, pět. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Mě slyšíš dobře.
Zkusím ještě teda dole.
1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1. 1. 1, 1, 1. 1, 1, 2, 3, 4, 1, 1. 1, 2, 3, 1, 1. 1, 2, 3, 4, 5. 1, 2, 1, 2.
question. I forgot my alarm clock in the room on the desk front.
So, have you checked if the room is open? It's locked. So, okay, I will try to arrange during the lunch break.
Great. I will come to you after this thing, or?
Maybe try to remind me.
Okay.
Yeah. But I will try not to forget. But yeah, I just need to ask security guys to unlock the room.
Okay, great.
I will find some room. Yeah, it's later. Thank you. Yeah.
There's no glass.
At this point, I
Yeah.
Okay.
I'm already making.
Okay.
he juggled, he did rap, he pulled
Last call for passengers on flight to XML.
and it was, you know, the real sad thing was that Michael Herbert between the bad and the good.
So can you test the microphone? Take this one. Test.
Test. It's working.
Yeah.
Yep.
So thank you for getting back on board for the rest of the conference. So we will have now 3 presentations before the lunch. And we will start with a presentation about still about the browser and still about editing in the browser. So we shall see what happened with Martin.
Yeah,
Thank
exactly. Even about XPath in the browser fully. My name is Martin. I'd like to talk to you about soft validation in our editor, Font.xml. I'm a developer at Font.xml. I've worked there since the very beginning, almost 3 years ago, I think. We all know what Font.xml is, but I can imagine some of you won't be familiar with it. This is Font.xml. It targets non-technical authors who are used to Word. We try to impersonate Word so that an author feels safe and can just work and keep on working, just like the older versions. It's very visible, nice. So if I place my cursor around here, this is our docbook editor, in which I wrote my paper. So as you can see here, it's quite easy to see. We've got save buttons, we've got clipboard buttons, we've got spell checking, and even more important, we can see how the structure looks of the document. We can see the source of the document. Most of the users don't really use it, but it's good for demoing purposes. And it feels really like Word. For instance, Ctrl-B makes a piece of text and emphasize piece of text. I now need to defocus the editor. Yeah. So let's now talk about schematron. I think most of you know what schematron is. Just to summarize it, it's a way of describing business rules over XML, which can't be expressed or shouldn't be expressed in XSDs. It's basically a set of queries for nodes and a couple of assertions and tests for business rules to assert it over it. For instance, this is an example schematron document. We have a paragraph, and all paragraphs should have a class. If a paragraph doesn't have a class, a message should be shown to a user, schema architect, essentially the end user of the schematron engine. That paragraph should have a class. I'd now like to show you how schematron works in Fonto. For this, I've integrated the docbook schematron file, which is available on the docbook documentation website. And just one highlight of it, it defines footnotes should not be nested. So any footnote in a document should not have another footnote in it. I've integrated this in the Fonto editor, like this. If I now open if you open the editor, you can immediately see there's a small piece of orangey stuff. And when you click it, it shows you there is a footnote invalid. We can click on it, like this, and it scrolls into view, and we can immediately see this footnote is invalid. I've actually rewritten the schematron rule a bit. It defined all footnotes being invalid if they contain footnotes. I've written it the other way around to say a footnote is invalid if it's in the if it has an ancestor footnote. So we can now see an author won't really understand these kind of messages. A footnote must not occur in the sentence a footnote. In the actual editor, we will prevent this, but just for demo purposes, I've disabled that. So I can now say, well, how to fix it? I don't know. The best way to fix all things is just delete it and gone. We now see no content issues, and everything is happy, everything is glad again. This is auto-saved, so it's done. I now need to defocus the editor again. Yep. In Fonto, we want to make everything live, everything as quick as possible. So an author doesn't have to wait, doesn't have to take actions or whatever to see what they are doing. They want immediate feedback. So one of our clients has over 3,000 generated schematron rules, 3,000 unique rules asserting something about an element. They all look roughly the same. Because we generated them, we can make them slightly more easy to evaluate. For instance, this one defines all chunks being an achievement kind of chunk. We're having a chunk body, and then look into the descendants, which are ordered lists, which are achievement lists. We assert there must not be any list items in it, not having a class. It's a bit a roundabout way of writing it, but it's basically the same. We can't run all of these 3,000 plus schematron rules every single keystroke, because every single keystroke may invalidate a rule one way or another. For instance, if I create a footnote here, insert, don't be scared about the huge thing. I'm gone again. We inserted the footnote here. The rules must be evaluated, so it can be solved again. We've got a couple of options of running all these 3,000 schematron rules at once. We can do them server-side. There's a slight delay, there's a server component, which we don't really like. We can make a huge update button for the user. So a user can manually check it, start a check, which takes about 5 seconds maybe, which isn't acceptable for every keystroke or any new element created, but it's after a button maybe. Or we'll do it live. Obviously, we chose the last options, because it's more awesome. For this, we need an XML engine in the browser, because schematron rules can essentially be rewritten to XML queries, matching all nodes which are invalid. For this, we implemented a XML 3.1 engine, so that we can use it in other APIs. We use it for instance, how we set up commands. We can really use the maps and arrays features and those kind of things in the rest of Fonto. So how did we do it? In the earlier talk, we saw some other approach. We first parse an XML expression, of course. For that, we used Peg.js, which is slightly different than Rex.js. The main features of the differences of it is that it defines another dialect for a grammar, in which we can output. We can choose to output AST nodes or choose to don't output AST nodes. It supports inline JavaScript for that. We then output an AST, abstract syntax tree. Since we're a JavaScript editor, we began as a JavaScript editor. We do it in JSON. For instance, it looks like this. This is the equivalent of the //node XPath. So we can see absolute path has a descent or self-axis, which contains a kind test, which is node. We interpreted it, and we transfer it to JavaScript objects. We save the abstract syntax tree in a IndexedDB, so we can cache them and can reuse them to mitigate a next parse hit, essentially. Also, Fonto comes back. Fonto users come back to Fonto, so we did it in IndexedDB, so it's saved and persistent over different browser sessions. Because the parser generator should be deterministic, it should always generate the same AST for the same expression. It's easily done. We then execute the export expression, which is basically making parse the AST to different JavaScript models. We use it in a roughly object, an approach to it, object-oriented. We then resolve the functions, a small bit of static type checking. So when we reference the function access string containing one argument, we add to one, we map that to the corresponding function. If someone tries to execute the function access string with 5 arguments, we throw in a static error. So it's really easy. We propagate variables on a dynamic context, which we just pass around and wrap and scope and scope. So it's the engine currently, I just looked it up, weighs in at 160 kilobytes minified. That's 37 kilobytes minimized and gzipped. Dus it is a bit smaller. And remember, that's the compiling phase, the parsing phase, the executing phase, all of it in just one part. We aren't complete yet, we aren't spec complete. The main points we're missing is inline functions, which would be really nice, I really want those. And some other features which we don't really use, like access pattern. I haven't seen use case for pattern matching in XPath yet, in our implementation of it, and our use of it. Because we only use it inside our own product. We don't market it as another product, so we can just do it. We need instant feedback. If an author creates an invalid structure, some way or another, for instance, there are some business rules we don't want to enforce so as hard as, for example, nested footnotes, like maximum character count in the title, maximum word count, minimum word count even. Valid date, it's really hard to write a valid date in one keystroke. So we want instant feedback for some of the things we do restrict, like too many elements of a certain kind. We have non-technical authors, so they don't want so they won't be able to remember exact schema constructions, and they really need to be guided. So we go to the next part: how to do this whole thing live. We can do 2 approaches. Roughly what Section.js does, we just optimize the queries to death. But still, remember our client uses 3,000 unique expressions, 3,000 unique queries, which all need to be run at the same time. Or better, we can just run all the affected queries. Not all actions will invalidate the same rules. Some won't, like text insertions won't matter attribute validations on other levels. Attributes edits won't affect maximum word count, maximum character count, usually. So we built a simple dependency tracking configuration. We essentially capture all the DOM accessors, all the changeable DOM accessors, so not node name, of course. And when it happens, we record a dependency for the kind of change we have. So for instance, if we look at a node's parent node, the child list if the child list of the parent node changes, that relation could have been changed. For siblings, the sibling relation could be changed if the child list of the parent changed. For character data, the character data changed, the observed character data changed, if the character data of the node changed, etc., etc., etc. Same for attributes, same for all. We then used a DOM standard called mutation observers, which is implemented in our own DOM implementation as well, which has a couple of nice features we can use to see if a query invalidates or not, an export expression invalidates. We can look at the type, and we can look at the node, and essentially using those two items, we can see which queries have changed. It's a bit abstract, but of course, I've got a demo over here. This is some code we also host at xpath.labs.fontoxml.com, which is the sandbox environment we use for testing. But if we look here, the above expression is the simplified expression we saw a couple of slides earlier. I've removed all the attributes because it's a bit long and the resolution isn't that high. But if we look over here, yeah, I've made all the nodes which can be, which are in the result of this query, gave them a red background, and all the nodes which have been touched, which have child list dependencies, I've made them green. The gray ones aren't touched, aren't evaluated, because we can see here, in this XPath, we walk to chunk, we then walk to chunk body, we then walk to ordered list, and we then walk to list item. Observe, I've made this a direct child one, just for simplicity's sake. It runs, yeah, it runs. If we do this, of course, the paragraph might indirectly contain ordered lists, using some way or another. So just for simplicity's sake, let's do this. And we can immediately see, when we change text here, when we create elements here, like for instance a bold tag, it can't affect the result of the original query, because the original query immediately goes to introduction and then immediately goes to chunk body, so it ignores the whole introduction element. Because the schema we used 3000 schematron rules with looks roughly like this, so it's really nicely balanced. We can get away with it. Also, if this thing here included a attribute check, which I should do here, of course, and not on the other page. Something like this. We can see nothing matches, and we add the class on here. We can do this because this one was green earlier. We see it matches again. So it got invalidated by this attribute change on the top level. Are we done now? Not nearly. In the future, we'd like to involve some kind of static analysis, type analysis, partial querying, partial reuse of partial results. You can imagine if 7 XPath queries look at all footnotes in the document, we can reuse that partial result, even if it's transformed later. So we can only have to traverse the whole document once. And in conclusion, the client is really happy. The client can type, the client can work, even with that insane amount of schematron rules. It has really good typing performance. We range at 30-ish milliseconds per average keystroke. And element changes, you don't even notice them. And also the editor I just showed will be available next year for all speakers to write a paper in, because someone won't like Oxygen or whatever other editor. Fonto is slightly more of a non-technical author. I can imagine there are not a lot of non-technical authors here, but it's good to mix it up every once in a while. That's all. Are there any questions?
Thank you very much. So we have 2 minutes for question. So any question?
Over there.
Just over there. Okay, sit.
Thank you, sir. Pretty impressive stuff, and one can see other possible uses for this besides what you have in mind, actually. I can see this as being pedagogically quite useful. But I'm curious, in this very clever idea to ascertain which, oh, I'm sorry. First, I should just mention as a side comment that I don't think, besides little test schematron files, I don't think I have a single real schematron schema in my system that doesn't require regular expressions, pattern matching. But anyway, in this very clever idea of trying to find out which schematron rules might be affected by a change here, if the user types a character, you have and you're looking at the XPaths that might be involved with this character, but what are you comparing that against? The context node of the schematron rule, or?
Well, for every DOM access we do, for instance, we retrieve a child node from a given node, and then retrieve a child node from that given node, and then a descender from that given node. We introduce a direct child list dependency on the root node, a child list dependency on the node below. So it's all, we start from my context node, but then it just wraps around. It flows over, essentially.
So, but how do you decide? So, given that you know now which nodes are involved, how do you say which schematron rule would be affected by this character and which wouldn't? You now know this area has these dependencies. Which schematron rules have those dependencies? That's what I'm asking.
For that, we just map. We save the dependencies on a schematron rule instance. We parse it and we transform it into JavaScript objects. And on that thing, we just save the dependencies. We loop over all schematron rules. We see, has this been changed, has this been changed, has this been changed, given the mutation records.
Right, and when you're looking at those schematron rules, you're looking at the rules context attribute, or you're looking at every test and select attribute inside the rule?
We instantiate the schematron rules. We instantiate the schematron rules and the schematron asserts and schematron tests. We append the rules and the tests and the asserts into one huge XPath, and we save that on the schematron report instance, which can be invalidated, which can be rerun, which can do anything you like. Pleasure.
Thank you, Sid. Another question?
More questions?
Okay, thank you very much.
Yep. Thanks.
So next speaker is Liam Quinn, that you may have seen once or twice over there, going to present us what's happening in the text edition world those days, with some feedback from the W3C perhaps.
Yeah, if I can figure out how this thing goes on.
So you just put it on your ear.
Like this?
Yep.
Oh, I see.
Like that.
All right, I haven't connected yet.
Is it unplugged?
No, I'm plugged, but not...
Okay.
Yes, that's... anyone recognize that? Snow. Yeah, it is actually taken fairly near where the demo jam is. It's at least in the same city, it's Prague. All right, good afternoon, good morning, whatever it is. My name is Liam Quinn with the World Wide Web Consortium, and I have a slightly strange talk today. It will be a lot less strange if... there we go. All right. Improving text quality with automatic majority editions, otherwise known as making OCR more awesome. This originally came from a poster I put up at Balasage, and someone, a gentleman sitting over there, said he was very interested in this. And you can look away, Sid, but it's all your fault. And, and I spoke with a few other people, and they said, why don't you give a paper on it? So here we go. The idea is that we're all used to working with XML, and a lot of us have authors or we do conversions, but quite a few people I've spoken to are taking text files. And in fact, quite a few people I've spoken to are taking text files from places like archive.org or Google Books and turning them into ebooks or dealing with them in some other way. And it's a fun thing to do. And I wanted to have some texts in XML. I wanted to have some dictionaries that I could make use of and do interesting queries on. And in fact, originally I wanted them in SGML, and on a trip to Oxford in 1991, there's all these bookstores in Oxford. It's very dangerous. I bought a 32-volume set of encyclopedias of biography from 1810 up to about 1818, I think the last one was done. This is actually someone else's set. I meant to photograph mine before I came and forgot, but it looks very similar. So there's 32 volumes. They're each about 500 pages. And each page, there's 16,000 pages, roughly. It's not the Dictionary of National Biography, which was the Oxford Dictionary. It's Chalmers' Biographical Dictionary. It predates the Dictionary of National Biography by quite some time. But it is the same kind of thing, yes. Plus, this one talks more about people who were not actually from the UK. Which I'll show you a couple of pages. It doesn't really matter if you can't read this. This is just a picture of a page, a rough outline. But the thing to notice here is there's entries. The first one is Courtois, James and William C. Cortese. And the next one is for Gilbert Cousin. And it goes down nearly to the bottom, and there's a footnote giving the source. And then we have another entry beginning on the same page. So they're quite easy to find the entries if you're going through a text version of this, because you can look for capital letters at the beginning of the line. After a while, you'll notice at the very bottom, I've got volume 10, B1. Does anyone know what that is? Signature, yes. When you, in the 19th century, actually it's still done today, if you look in many printed books, you'll find typically on every 16th or 32nd page, or if it's a larger book, every 8th page. On this one, it's every 16th. You'll find letters at the bottom, something like B1 and B2, B3. And that's so that the person who collates all those folded sheets of paper that we've printed on puts them in the right order. And they're very clever here. It's fairly unusual. They've actually put the volume number of the encyclopedia in as well, suggesting that they had multiple volumes in the printing house at the same time, but I don't know if that was true or not. Things like this are actually a pain when you OCR because they come in as part of the text, typically, and you have to get rid of them. But you can be clever and notice it's every 16th page. And all right, we don't need that one. So, I have in fact these days a museum quality flatbed scanner, which is an immense thing that can do A3 or tabloid, very accurate. And I did in fact try scanning a few pages and using Abbey Fine Reader, and I found I got 1 to 3 errors per page with a little bit of work. Maybe 10 minutes, 5 to 10 minutes per page, maybe 1 or 2 minutes if you got practiced. But it would destroy the binding of the books and leave me with thousands of pieces of paper, which was a different kind of management problem I really didn't want. So I abandoned the project. And then one day I happened to discover that Google Books had scanned this set of encyclopedias. Now, what Google is doing is they're going to research libraries, and the deal with the research libraries made with Google is that the result would be placed on archive.org and available for free use. And these texts are well out of copyright, so anything that you find in there saying this is for non-commercial use only or is a load of baloney. And that has been tested in court and checked. But what they do is they go to a library shelf and they scan the whole shelf. They take all the books, they scan them, and they put them back, and then they do the next shelf, and then they carry on, at least conceptually. And meanwhile, in another university, in another city, they're doing the same thing in a different library. And it turns out that sometimes there's more than one copy. So I did a look on archive.org, and I found 157 files for this dictionary that only has 32 volumes. So that's an average of roughly 5 duplicates for each volume. So I said, okay, I downloaded them all over a period of several days. So click, click, click. And the metadata is really sucky. It doesn't tell you which volume in the metadata. So I sorted them into scan sets and by volume and checked that they were all the same edition, which they were because there was only one, which is interesting because it constantly talks about the previous edition of this work in footnotes, but in fact there wasn't one. And I chose the best of these 5 or 7 sets. It varied. Sometimes there were only 2, sometimes there were 7. And started a conversion project into XML, and it was all very exciting until I actually looked at the quality of the text in more detail and discovered it was really awful. And so I found, well, let's look at one. So there's the archive.org page, for example, for a search page, and you just get all of these. You can see the title saying the General Biographical Dictionary revised by A. Chalmers. Some of them have a slightly different version of the title. So you have to be kind of liberal in your keywords when you do the search. And I can't actually tell if there's any duplicate volumes in that one or not. I think there are on that page. So my initial conversion is was actually a set of Perl scripts. This was like a decade ago. And they do things like identify the running headers and so to get the page boundaries and delete those signature marks. Delete the part where the Google operators have typed 00000, meaning it's time for lunch. I'm serious, you find this, and I actually did searches to discover what these series of O's meant that appear in Google Books, and it turns out it's communication between the camera operator and the scanner operator, they're different people. I put these, time for lunch, time to go home. So conversion scripts do tons of tests, and I really want to emphasize this. So for example, each page is logged, and if we skip a page, then it prints an error message to a log file, and if we try and go back a page, then it aborts altogether and says, Liam, you've got to fix this. And in fact, that's how I know there's over 16,000 pages, because they're all accounted for. And then I had a brainwave, which was why don't I match up corresponding lines of text in all these versions and choose the best one? So that is what I did. Let's, the easiest way to do that is, for some reason F11 doesn't work. I need to put my eyes on for a sec. So we could look at the script, but I'm not sure that's very useful, but what I'll do instead is show you the result of running it, and then if anyone wants to, we'll look at the script a little bit. But what the script does is it runs through all the versions, a line at a time. Strictly speaking, this is, if you've got 5 texts, the complexity of this is n to the 5th, but because it will never go more than 200 lines further down, which is about 4 pages, it actually runs in reasonable time. Complexity theorists would say that's silly, you're n to the 5th, and limiting it by 200 doesn't change that, but in practice, there's a big difference between 20,000 to the 5th and 200 to the 5th, which is the difference between about 1.5 minutes or 2 minutes to run this in about 3 weeks. Right, I mean, so it runs reasonably quickly. And the way that I use it is it produces output, choosing the best version for each, choosing the majority version, rejecting ones that add certain specific OCR common errors. So a common error, for example, is having curly braces in the middle of the document. Let's make this big. Oh, a little bit bigger. So this is a diff output for just a standard Unix diff, comparing the original, which is lines with a less than sign at the start of the original and lines with a greater than sign of the replacement. We can see, for example, about the 5th line, we've got he afterwards spent some %VA GIMO. Well, that's no good. And it's replaced with he afterwards spent some time in Denmark. And I can't see the difference from here on the next line. It's probably a comma. Received. Upper and lower case. The first of those, the original has an uppercase R in received. I don't know why. It's possible that's a difference in the printed books. Even though it's the same edition, sometimes what happens is while they're printing the book, someone notices an error. And they've done 100 copies here, they've got 300 to go, and they get a pair of tweezers, they loosen up the form, take that one sort, that one piece of type out and put the right one in, tighten up the form and carry on. Right, and it's the same edition, these days it would be called the same impression, but there's a difference. If I was trying to do something really academically critical, I would go and check. But because of the level of errors in this, that's a pipe dream. And I'm never going to be able to do that myself. Here we've got, I did want to point out, here we've got col star should be CUL hyphen, so cultivated and cultivated. It is actually possible to use spell checkers, and Project Gutenberg has a program that tries to do that. I've tried to do it, but I found that there were too many differences, legitimate words that spell checkers hated, and too many problems. And a lot of that's just because there's so many proper names in this text. But for some texts, I do have a version of the script that can do spelling. Okay. So now we have done that, what do we do next? If I'm lucky. I want to talk a little bit about the context of using scripts like this, because you can get yourself in a big mess if you're not careful. So you've really got to be quite careful to make sure, for example, you've got all the variants are in a subdirectory all by themselves for each file. And you don't end up with multiple files around and you can't remember which is which a year later. It really helps to use a revision control system of some kind, which I didn't early on and regretted, because I normally do. I don't know why I didn't start out doing it. And then a week later, I discovered I'd accidentally deleted all the semicolons in one of the files. Luckily, I was able to put them back in programmatically, but it helps a lot. The way that I do conversions, and I know a lot of other people do them this way, is to have it's not unusual to have a dozen or even 24 small scripts that you run in a pipeline. You can't use XProc1 because the stuff at the beginning is not XML. It's text with random angle brackets in it here and there, and XProc really doesn't like that. But you can use make, or you can write a shell script. If you're an MS-DOS, you can write a bat script, but I recommend make. Even if it's something, I guess yesterday Norm was showing us a version of make written with XProc, but then you have to deal with the markup in these Google texts is there's about 200 to 500 lines of crazy HTML metadata, which is mostly garbage, unfortunately, as far as I can tell anyway, and then a pre tag, and then an entire book as ASCII text, and then an end pre-tag, and then end body, end HTML. That's what you get as input. And here and there, it may not even be well formed. So I have lots of small stages, and I manage those with make. So you run something that identifies pages, and that makes versions of the files with the page breaks marked. And then if you edit one of those files here, make says, you need to run that phase again. But if you're over here and you edit one of the scripts, for example, then make will say, I don't need to run this early stuff again. We can just go from here. And it doesn't save you a huge amount of time, but what it does is it makes a huge emotional difference, because you can make a quick change to a script and you're not running everything from the beginning. And that should not be underestimated. And each stage, it's important, logs any problems. Ranging from my Saxon license has expired through to things like I've got a superscripted number on this page, but I can't find a footnote. And then I can go and look. There are not that many footnotes that I can fix those by hand. And you make a decision. At what point does the conversion stop and bail out and fail? And it's usually more useful if it can continue as much as possible and you get a result. So we should look at a result. And I think I have one that I prepared earlier. That's what they say, isn't it? Okay, probably. Let's scroll down. I had this vague idea that I would get rich off ads on these, but I should just take the ads off, like $1 a month or something. So here is the result of the OCR text with a footnote at the bottom, links to alternatives, and the thing at the top is SVG that's generated in the XSLT that splits the final XML into 10,000 small HTML files, one for each person mentioned, showing the born and showing birth and death and published works. And that's another check. If the published works are way after the death date, then sometimes you wonder were they published posthumously or is it an error? If these two blobs are too far apart, if they're more than 100 years apart, turns out there's only 3 people, I think, in the dictionary that lived to be significantly more than 100. Right, so you know that there's probably an OCR error in the death date, and that does happen sometimes. Someone has a death date of with a 7 instead of a 1 at the beginning or something. They lived a long time. All right. I've almost witted on. I'm sure I have witted on too long. I don't know. How am I doing for time? Someone? Anyone? So it's not as good as proofreading or rekeying. I've found typically 2,000 replacement lines per volume, this method with the first version, and it's somewhat better than that with a revised version that looks within the line and is slightly smarter. The one in the paper only does a whole line because it made the script too complicated to explain. This is massively faster and cheaper than proofreading, on the other hand. I've searched for some other books. I happened to pick up a dictionary of architecture cheaply in a bookshop in Ontario recently for $5 or $10 from 1840. And there's a dozen versions of that on archive.org. So they're still doing it. It's still happening. And since I downloaded all these files for the Chambers Biographical Dictionary, I see just in the last week another set of 32 files has been added. They're actually not very good. They're from India, which isn't why they're not very good. But these particular ones are not very good because they're just images in PDF. There's no text. They didn't actually do the OCR. And that's a project at the University of India, which is why I mentioned where it came from, that is doing a lot of that. So you encounter that a lot. What am I doing in the future? A few things, such as trying to find, I've already identified, I think, all the poetry by the fact that it's indented. But Greek comes out as random letters and sometimes random italic letters, or with underscores or random capital letters. Context-sensitive fixes is things like, if we're talking about someone who lived in Oxford and went to the University of Oxford, and then 2/3 down the page we have the University of Orford mentioned, we've got a good idea that it doesn't mean Orford, it means Oxford. For one thing, although there is a town called Orford in England, it doesn't have a university in it. So that would be a clue, but in general. So trying to do something kind of situational semantics-based a little bit, but that's ongoing research. And one of the steps I haven't mentioned before is the final step that I do before publishing is I run a script that I wrote a long time ago that that adds cross-references. It adds links, even where they're not marked in the XML. So if it finds someone's name and that name is a head word in this dictionary, then it makes it a cross-reference. If it's a name in any of a dozen other reference works that I have, it makes it a cross-reference. And sometimes they're wrong. It just adds to the fun, right? And, improving the checks back is something I'm still working on. I've done quite a lot of it. So one of the encyclopedias is from about 1900. I would like to have an earlier one that's more contemporary with this, but 1900 encyclopedia. And it marks population of places. So if we've got a person name with a population, that's an error, and I don't do the link. So it's all about lots of little checks. Okay. And on tomorrow, I will talk, in my talk about W3C and IDPF, I'll talk a bit about where books might be going as a result of this merger and ebooks, and some of the ideas about how you contextualize books and kind of explode them and do some of that stuff. And I would like to use this as a test bed for that. But I think you can, there at the top link there, if you can read it, I apologize for the low contrast. The top link is to the actual dictionary. The bottom link, the middle link is to words.fromallbooks.org/XML. That is where this stuff will go. It was too big to upload during the conference. I mean, if I include all the text, there's several gigabytes. And didn't seem right to do that in the middle of the conference. There's 150 versions of the, 150 text files and all sorts of stuff. And I think, well, I'll just put it all there. But okay, I guess that's.
Thank you.
Sent everyone to sleep.
Any question? Oh, yeah, over there. Okay, bring the microphone.
Liam, it strikes me that what you're dealing with has got a pretty regular typographical geometry basically involved in it, and that's not terribly complex from that point of view. If you want to go a little bit further, I can recommend that you look at the work that David Brailsford did, which is reported on in ACM.eng, where he tackled the problem of reproducing, using trough actually, the births and marriage and death registers from printed material, which goes and explores when the thing gets a little bit more things with tables and that sort of stuff. Some really excellent work that he's done there, which he should do, given his background. So I suggest strongly you look at that work and give you the references.
I will, thank you, yes. I should say also, I haven't really shown you any of the more complex things, such as the fact that footnotes are in 2 columns in the book, and the OCR doesn't actually understand that, so you get alternate lines of footnote next to each other with just a 2-space gap between them, or sometimes a 1-space gap. And sometimes I can undo that and sometimes not. The alphabetical order is not in fact perfect in the books. So my scripts check it, and it took me quite a while to get past that, the putting exceptions in. So it's slightly less regular than it sounds, but we don't have any tables in this, thankfully. That's true. Okay. I think are we out of questions? Good, thank you very much.
Thank you very much. I had one last question. Why isn't open source the code?
I'm sorry?
Why the code is not open sourced?
Well, it will be. You'll be able to download it. I
Okay.
thought of putting it on GitHub, but I didn't want to deal with pull requests.
Okay.
But I would happily do that if anyone is interested. I will happily do that.
Okay.
Otherwise, I'll just make it available for download.
Super. Thank you. So next presentation. You start? Okay, yeah. I prefer if you take this. If you come to last minute. So next presentation is in 2 parts, if I understand correctly. So can you test the microphone? Louder?
Now it's better? Okay. So, hello. My name is Mershat Zairi Esfahani. I think this is the most difficult part of our presentation. I'm the founder of ParseCube in Germany. And we were talking about 2 or 3 years ago, we were talking about the problems that we are faced to in the publishing houses. So the problem is actually that people, the authors who want to write the books, they just bring their manuscripts, and they are maybe in Word documents, or they are maybe in InDesign documents. And the problem inside the publishing houses is actually, I think a lot of you know about this problem, that they don't really care, the authors, about the structure of the document. So it costs a lot of money to work it out and bring the document in a proper structure. So in one of our talks with the publishing houses, there was a really nice there was a nice part where one of the bosses of the publishing house told us we have some problems with a semi-biomechanical process in our house. So I had no idea what it meant. So I said, excuse me, what is it? And he said, well, this is actually a manual process. So this is why it's called the biomechanical. And there is someone sitting on the computer and just checking the structure of the Word document, for example. And then they make it in the proper way, and then they can start to produce the books. So I said, okay, I know now what a biomechanical process is, but why semi-biomechanical? And he said, well, it's not totally manual because these people are working with a computer. So I thought, okay, now something's wrong because actually we have all the yeah, all the techniques to use the technique to make this semi-biomechanical process to a sort of full automated process. So, and yeah, it was something about 2 or 3 years ago we started with this process. The idea was talked and exchanged between me and Manuel Montero from Data to Type. And now we have a sort of solution. It's a free service that we built up. That means we can use this service. It's free to use. And I hope that a lot of you would use this process and just give us some feedback how you find the process. So you can upload your documents. It could be an IDML document or it could be a Word document, and then let the process of proof of the structure. It could be automated. You can do it not in a biomechanical way, but in a totally automated way. Well, the people who really made up this process, who wrote the program and all this stuff, this is my colleague, Mr. Hauke Brandes, and this is Nico Kucherara, who is somewhere there, yeah, up there. And now we don't really want to show you some presentation, but we are going to show the process in a live presentation. Please.
Okay. So, what is this service all about? As Mershad told you already, it's about automatic proofreading of documents, and it focuses on docx and IDML documents, so Word and InDesign. But it aims to be a platform, so we have additional formats which we basically support as well, but not with our own implementations. We support EPUB proofreading by using the EPUB checker, the open source tool. But that's basically just a proof of concept, how we can augment the platform with additional formats. So, the platform allows to check or validate the documents that the authors may directly upload into the platform. And the results are either generated as HTML reports, so you have a nice report and can look at what is wrong with your document. But a very interesting feature is that the results may be integrated into the original document as well. So you can see, you can download a modified version of your document with inline comments and notifications about where were problems and what problems there were. Okay, in addition to validation, we offer a conversion service to convert the documents into a generic version of XML, which is configurable as well. So if there are existing XML workflows in the company using the tool, they may use it as a first step to get a reliable version, XML version of the docx or IDML document. Okay, as we are offering this platform as a service, there is a simple, at the moment really very basic collaboration model, which means you can register as a group on the platform, and you have different permission models. You can have, for example, if you're a publisher and you want to define rules for the documents for your authors, then you may do so. You can configure the rules via a graphical tool, and then you can give permissions to your authors to validate, but not to edit the configuration. So you can you have a very, very basic model that you are sure that your author may use the platform, but you are in control of the rules that are validated. Okay, so we should look at it perhaps live. And this is basically what it looks like at the moment. I am already logged in, and I can see that this user has one validation configuration for a docx workflow, and he already validated a document as well. So let's see how this works in practice. If I want to create new rules, we don't start we don't start from scratch, but because it will be too complicated for many users to enter the right IDs for paragraph formats or character inline formats. So we say we have a different approach. We use a template document which contains all the features that should be allowed for an author to use. Every character format, every paragraph format that should be allowed for the authors to use must be present in the document already. If the author is allowed to use images, at least one image should be in the template document. So you basically create a document with all the features that should be allowed to use and use that to create an initial configuration. So you can do this. We've got a very simple Word document file here, which I upload now. So the document is uploaded to the platform, analyzed, and an initial configuration is created automatically, which I can modify now via this configuration dialog. So first of all, I've got an identification. So I say perhaps this is rule set for books, blah, blah, blah. Anything goes. And here I can do some description. Here you can see the simple permission model. I can give other users of the platform the permissions to edit this configuration, and I may give other users of the platform the permission to use this configuration, so to use it to validate their documents. Okay, we've got several different components. Perhaps the most important one is the rules for the basic document structure. So we can do some constraints about the order and the nestedness of the different paragraph formats. I can say I want the first paragraph of the document to be of a specific style. All these paragraph styles, which you can see here, were extracted from the template document, so I didn't have to enter them manually. I can say it should not be one of these, it must be one of this list, or I have no restrictions on the first element. I can say for any other paragraph style, for instance, that it is only allowed after specific other paragraphs. So I've got a paragraph style here for the abstract of the document, and I want the abstract only to be possible directly after the document heading. So I say I have a restriction. The previous paragraph must be from this list, and it must be the document header. And this is all I have to do. So I've got this rule configured now for the abstract paragraph style. Okay. Furthermore, I can restrict what inline formats are possible in the different paragraph styles. For instance, I want to disallow link styles in headings or anything like that. I've got a different section here. The character styles in the abstract paragraph style that are allowed. I can say I want to disallow the intensive. This is a citation format. This is a default name from the German version of Word, so bear with me. This is not English. It comes from the template document. Okay, whenever a rule is violated, I can enter a comment which will appear in the modified version of the document afterwards. So I can explain to the author here why, for instance, the document header must be immediately before the abstract paragraph. Abstract is only allowed directly after. You get the picture. I can explain the author why this rule is in place at this moment. But this is optional. This is just to give the authors a clue when they validate their documents. Okay, so I can do that for any paragraph style. So some very basic structure configuration, which I can do here. And in addition to that, I can see what kind of character styles were present in the template document. And they are all allowed by default if I don't restrict their usage in specific paragraph styles. Okay, so this is what I can say about the structure of the document. Another little tool which we built in is mainly used for, or it can be used for a lot of things, but the usage scenario we had in mind was to detect and repair certain microtypographic problems. Like, for instance, abbreviations which are sometimes used with spaces in between the abbreviation or not. So I can say that I find all instances of EG, for example, with a space in between. This is just looking for them and marking them with a comment. But I can also do a replacement directly and say, it's just a global search and replace in all the document. I want to replace it by EG without a space, for example. It's also possible to do this with regular expressions for advanced users, of course. And as always, you can write a comment and rationalize this rule for the author. So we had, for instance, several usages of D2C, and I want to enforce that D2C, which is short for data to check, of course, should be written in uppercase letters. So this is this component. We have got a global configuration about what additional features in the document are allowed and what features are disallowed. So one important thing here is the use of pictures, of course. As there were pictures in the template document, the default is that all picture formats are permitted. I can restrict the images to be embedded or not embedded, and I can restrict them to be absolutely positioned or not as well. I've got the possibility to say that if I want to go to print, I want to enforce all pictures that are used in the document to be TIFF pictures and not JPEGs or any other style. So I can say that change tracking should be disabled in the document. There shouldn't be any change tracking annotations or comments. I can disallow text boxes and shapes and all kinds of stuff. You can basically disallow everything which may hinder a clean publishing process afterwards. Okay, as I told you already, we've got also one component that transforms the document into a generic XML structure, and that XML structure is based on the names of the paragraph and character styles, which is already pretty good, which is pretty usable. We have often found that it is enough to have a really good XML source for further processing without any further configuration. But if I want to configure this generic XML, I can do so as well here graphically without editing some source code also. So I can say the root element should be a specific name, so maybe it should read document instead of our generic root level element is called root, I think, which makes some sense as well. I can rename any further element, so any element which represents an abstract paragraph, I could rename them to, I don't know, summary or something like that. Okay, so you see it's pretty basic. You have not the full power of doing programmatic restrictions, but on the other hand, it's very easy to configure and to use. So we save this configuration because we want to check if this works at all. So I go to the documents section of the platform, And here I can see what kinds of checks are valid for this for the current user. There are some validations that are built into the platform and not configurable, so they are usable by any user of the platform. This is the usage of EPUB check, for instance. There is a basic IDML validation that checks if the IDML will probably not cause any problems when going to EPUB, when converting to EPUB from the IDML directly. And we've got the specific configurations which we have configured for ourselves. For instance, the rule set for books, which I just configured, is available. So I want to check a file. I will check the same file which I've used as a template document now, because it probably won't be valid anymore. It was valid when I created the initial rule set, but I modified the rule set and I disallowed certain image types, for instance. So we expect that there should be problems when we validate this. Okay, so we upload it and look at what happens. And I hope something happens, yes. Okay, so we've got the result list here of any document that I have already checked. And the result is that there are some problems, which is this little orange button here. So these are the artifacts which are generated by the validation. One thing is the annotated version of the document, which I can look at right now. So this is, perhaps I should have shown you the original document at all. So the original document looked like this. We had a paragraph format abstract, which you've already seen in the configuration. We've got an image, we've got some inline formats here, and well, it's just a very basic Word document. And what we got after the validation looks like this. So, and it doesn't look like it should do, which is a little bit disturbing. Okay. This is my fault, because when I chose the file, this is something which may be optimized a little bit. I have to I have to select the rule set afterwards. So this was a different rule set with different character and paragraph styles, so they were all unknown, and we've got basically a very invalid document. So now we do the same thing with the rule set which we just created. And once again, we look at the commented version of the document, which is in my download folder. Now, this looks a little bit better. So, we have said that in the abstract we didn't want to have the inline format intensive citation, which is shown here, and this is the comment about this. As you saw, we can configure our own comments, but if there are no comments configured, automatic comments are generated by the platform. So the author can directly see not only how broken his document is, but also where in the document directly. And he can accept changes, for instance, for the replacements. We can insert them as change tracking events. So the author might look at every separate instance of search and replace operations and just say, well, this is okay, this replacement is not okay. So we've got a problem with the picture, and the message for this is the picture format is JPEG, which is forbidden because the only permitted formats are TIFF and TIFF, well, TIFF with double F and TIFF with F, because we only look at the extension at the moment. So, and we've got some other instances of our micro-typographic correction, and that is basically it, which is pretty nice if you've got a long document and it's basically correct, but you've got only some problems somewhere. You just look at the comments and you're ready to go. Okay, apart from the commented version of the document, we offer an XML version of the document, as I said, which is basically a generically created XML file with the same content as the document. And in some little instances, we might look at it. Okay. It's not Oxygen's fault, it's the fault of my notebook, of course, that this takes a little bit longer. Okay, so this is what our generic XML document looks like. We've got a basic structure with a head element and some metadata, which is extracted from the metadata of the document, either Word or IDML. And we've got the body, and the body is usually structured by the names of the paragraph styles which exist. So we had a paragraph style document header, which leads to an element document header here. We had a document style abstract, but I renamed it to summary in the configuration. So this element is not called abstract now, but summary. So I can adapt it to some specific needs of my XML, for example. But as you see, the whole content of the document is available, and it's clean and very easily structured XML, so it's very easy to process. On top of that, we've got the validation results in the form of swirl. So not all checks are implemented with Schematron, but some are, and we use it as our generic result format. And we've got also a version of the validation result in form of HTML, which looks like this. Okay, so we've got the name of the configuration which has been used to check the file. And we can see that we have had several problems. And well, we've got some details about them, and a very basic preview of the document in pseudo XML format. Okay, so that's basically what we wanted to show of the platform. Perhaps a little bit about the architecture which we have used. Okay, so just some of the components which are used here. The persistence layer for the whole application is an XSDB instance, and we've got distributed validators, which may be on any other computer, and the communication infrastructure between the web front and the validators, which are in their own processes, is Redis. So we use one big Redis instance just to do all the communication between the different components of the system. The verification pipeline itself is at the moment driven by XMLSH, which is perhaps a curious choice at first sight. This is based on our development model. We have developed the validation pipeline relatively independently from all the GUI stuff, and it was basically a bunch of batch scripts which called into Saxon. And this is not very good because it's for a very specific platform only. It runs only on Windows. It runs only on the command line. It's not integratable as a component. So we looked for a possibility to make minimal changes to the existing and working pipeline, but we wanted to be able to use them on any platform and on the command line as a software component in a larger architecture or whatever. And so we just transformed the batch files into XMLSH files. If XMLSH is not known, it's basically a shell which is implemented in Java with some specific XML functionality, which is pretty nice. It looks a little bit like XML enhanced bash. So we had got minimal portability issues when transforming from the batch files to XMLSH. And on the other hand, XMLSH is extensible via plugins, so we can integrate that script directly into our Redis infrastructure, So basically, we have really a shell script which runs and looks for validation requests automatically from the platform, which turned out to be pretty nice. But on the other hand, XMLSH is a project which deserves more love than it gets at the moment. So we are thinking about perhaps migrating the pipeline to Xprods. There were some technical issues why we didn't do it yet, but we may do so in the future. So where are we in time? Okay. Good. The front end is just your run-of-the-mill basic Spring web application. We have got several components which are logic-heavy and running client-side. We decided not to use JavaScript, but TypeScript, which is a statically typed JavaScript extension by Microsoft. And this turned out to be a really good choice, because TypeScript has a very flexible type system, and it allows you, for instance, to convert an XML or JSON schema, which you use for the communication with the backend, directly into valid TypeScript types. So you can not only be a little bit more sure when you write your configuration editor that you don't forget about elements or about the naming of any elements, but you have also great IDE support. You basically can type, okay, from the configuration I want to have the first element which is of this type, and this type says it contains an ID and a name, and you basically cannot go wrong at all. If you do any changes to your configuration model, you just regenerate your TypeScript types, and the compiler tells you where you have to adapt your editor so that it runs once again. So that turned out really nice. As I said, the validation pipeline as a component is now usable via command line, via a web interface, or via a very simple REST API. So it's easily integratable into very different kinds of platforms. But the basic idea behind all this is that it runs as a service, so you have got basically no installation problems at all. It just is there. You can find out if it suits your needs, and if it doesn't, the idea is to be expandable, of course, because we've got very basic structure tests now, which may be good enough for some projects, which are probably not good enough for any kind of project. But we want to have a platform so we can collect, perhaps, the needs of different clients, of different publishers, or of different customers, and integrate them back into the platform. So as the time is coming to an end, I would perhaps just ask if there are any questions about our tool or any of the related technologies. Okay. So, any questions?
Thank you very much.
Yeah.
Thank you very much. So, any question? Okay, I have an answer. Lunch is in 10 minutes. Now I need question. I have two there. One on top, one over there. Yes. So perhaps. Yeah.
Yeah, I had a question about the kind of structural checks that you were able to do.
Yes.
So you presented some checks that, for instance, you considering a paragraph, you checked the style of the immediate previous sibling, right?
Yeah.
Can you do some checks on elements earlier in the content? So I'm thinking about checking, for instance, that a headings hierarchy is properly nested. So you encounter a heading of level 3, and you want to check that it within the previous heading actually has a level 2.
Yes. Well, for the basic structure test, we only consider the paragraph immediately before one, but we have got additionally tests for the nestedness of the nested hierarchy of the headings. I didn't show it, which was probably not a good idea, but I can show you right now. Any paragraph has a certain function. A standard paragraph is just anything, but it may also have the function of being a heading level 1. And if you've got another type of paragraph, like I say now, Apocalypse Now is used as heading level 2, then the heading structure is checked always. I cannot even disable it. I can disable it by saying that there are no headings in the document. And if I try to configure it illegally, now I've got a format for heading level 1 and one for heading level 2, but none for heading level 2. This is already shown as an error in the configuration directly. Yeah? Okay.
Thank you. Oops. Thank you. Sorry.
Hi. I was wondering how you store your business rules, your validation rules, and whether you'd considered some variant of schematron to do so.
Excuse me, could you repeat the question?
Yes, sorry. I was wondering what format you use to store your validation rules, and whether you considered using something like schematron so that more complicated scenarios could maybe be integrated using schematron.
Well, we've got a custom XML format. As we do, as we use XSDB as a persistence layer, it makes sense to store the configuration in an XML model. And the model is specific to the different components. So we've got one configuration model for the structural rules, one configuration model for the search and replace rules. And this is basically the granularity of our component model in the backend pipeline. So if we want to augment the platform with additional tools or additional validation checks, then we basically only have to configure, have to specify a new configuration format. We write a GUI abstraction for it, so we can edit it on the platform directly, and we execute it on the pipeline in the end. So I don't know, does this answer your question? It's a specific format for every component. So we've got these structural rules, and there's a very direct representation of exactly these rules which are possible to configure in our XML model.
I was just wondering if there was maybe a trick that had been missed here to reuse an existing technology, maybe a bit more of a...
No, it's at the moment it's if we want to integrate existing technology, we would write a configuration format which allows us to specify whatever configuration an existing tool, for instance, may offer. But we have to do this abstraction step in between.
I did have a separate question. Is that okay?
Okay.
I was just wondering for the conversion into XML, if you've got any way of dealing with grouping. So, for instance, I've worked with word conversions for things like dialogues in plays and being able to group at quite low levels as well as heading hierarchies.
Yeah. There's some basic support for the structure which is imposed by the different heading levels. And there's one possibility if I've got, as I've shown you, that I've configured now that abstract is a paragraph which signifies a document, a heading level 1. And for heading elements, you can have, no, wait a second, I might be able to, oh, yeah, it's invalid at the moment. So, well, I can just tell you because we are running out of time. You can tell in the XML configuration if you want to have a wrapping element around the heading and all its content. Which, because that is something which often, when we process the document furthermore, is bad if we don't have the proper nestedness of the content and the headings. So we've got a feature for that already built in. But that is about all what we offer for doing more structural XML. Yeah?
Thank you very much. So now that's time for lunch. So lunch is upstairs in the restaurant. So if you're first time to the conference, then you just have to follow the crowd. Everyone knows where it is. And so be there in 1 hour. Yeah, be there at 14:30.
Yes, I've seen it on one version.
That's not the way you do it. You have your name of the speaker, who is going to speak, and you have to do that correct, so you can set up everything, no intro letter.
Yes, but Mohammed, I was actually asking.
Yeah, sure.
Yes, but I was actually asking before we came here.
I'm not sure because it's just some standard image.
So because there's two of us.
Or you prefer to send along
Everything is okay. But yeah, I know. I understand. I understand. Of course. I understand. Exactly. I understand everything. I understand everything, but there was a question. Okay, there was a question from my side, and of course, yes. So I didn't really want to discuss, but just accept your.
Yeah. I will switch you to the English keyboard. Yeah, because. Yeah, so now it's easier.
If there's a problem, So I think it's just unfair. You're talking about self-service. Okay. Yes, of course. Yes, I know. But I think it's not fair if you're. Yes, I know about that, and I accept it. But if you're now start like this and talking about self-service, I won't accept it as well. All right? Okay. I can understand your critic. Okay, that's fine. But don't. I hope you start talking about like this. Yes, of course, because they wrote me and I came down and I said, come on, Mohammed is actually waiting for you. Okay? All right. So I think yes, of course.
If someone from your people doesn't know, who else can know?
You were asking first of all, okay? And then you were talking with Roscoe. None of them is my contact.
I'm looking for the name on the
Yes,
list.
I see.
Okay.
Oh, I understand you, but I think now we are turning to a little bit unfair.
Okay.
That's it.
I will just.
It's no problem. Just want to make sure it works.
Yeah. Okay, cool. So I will just do the tab open and we will just switch to this scheduling. Yes.
This one doesn't mute. It doesn't mute.
Sometimes the mute buttons are. It's on the wrong side. And now?
It never mutes. So.
Well, we can switch it off.
Moc. Dobrý, já ho vypnu. Hej. Scuzo. 10, 9. Hej. Jo, teďkon takhle mluví dobře, ale já nevím, proč to tam dělalo. To je moc. Hej. 10, 9. Takhle. Dobrý. Hej. Hej. Zamutu. Hej, a teď je zamutovaný. Hej. 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 Ty vole, tam nejde. Hej. 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 10. Hej. Hej. Tak ho jenom stáhnu, ale ve sluchátkách. Hej. 10. Hej. Hej, no. Zamutovaný, tak to je v pytli. Hej. Hej. Hej, 10, 9. Hej.
Jedna, dvě, jak mě slyšíš? A když já tam ještě přidám decibely, já jsem je ubral totiž jako před chvílí. Já zkusím 12. 1, 2, jak mě slyšíš? 1, 2. Teď jsem dal plus 12, bylo plus 6 decibelů.
A teď to vypni.
Teď to vypnu. Jedna, dvě, ale pozor. Kurňa, teď jsem chtěl něco udělat. Jo, vypnout, jenom u té. Jedna, dvě. Jak já to zapnu, 1, 2 a vypnu.
Hej.
Mám zamutováno, teď už, hele, hej. A to mám zamutováno. Hej, tadadam, pam, dobrý. Zamutuje. Hej. To víš, jo.
Pojď tam dát zpátky tam.
Hej.
Vyměníme jenom ten mikrofon.
Square šláf, jasně, hele, počkej, já musím square změnit. Midle, height, tak já dám midle. A dobrý? Jo.
Je zamutovaný. Hej. Jo, počkej, dobrý. Hej. Už mi jde. Hej. 10. Ne? Hej. Hej. 10, 9. Jo. Hej.
Já tam zkusím dát ještě ten hike.
No.
Úplně.
Hej.
Budeš muset si hodně přidat.
Hej. 10, 9. Hej. No, víc je to. Takže přidáme tady. Hej. 10, 9. Hej. 10, 9. Hej. La. Tadadam, pam, param. Hej, 10, 9. Hej. Hej. Jo, bam. La.
A počkej, vypnu.
Hej. 10. Jo. Hej. Hej, jo. Hej, hej. Hej. Hej, hej. Ne. Hej. Hej. Hej.
Hajk, 1, 2, 1, 2, 1, 2. Co jsi s tím dělal? A proč to teďko nemutuje?
Hej.
Já tam dám love middle.
Hej. Hej. Jak se postavím tady někam? Hej. La. Hej, no. Já jdu dolů. No, jo. No. Tady. Hej.
Ty mikrofony. 1, 2. Jak mě slyšíš? To bude 5. 1, 2. 1, 2. Pilot tam je. No to tam vrátíme, tohle teď. 1, 2. Zeleně 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Jde to, že to skočí takhle, když je zamuto.
Tenhle vypadává.
Hej.
Tenhle je.
Hej.
1, 1, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 1, 2. Jedna, dvě, jedna, dvě, jedna, dvě, jedna, dvě.
Není rozmazlený. Já ho vychoval nejlíp, jak jsem uměl. Ne, je dobrý. Teďka je fakt dobrý. Konečně přestal zloupnit.
Jedna, dvě, jedna, dvě, jedna, dvě. Jedna, dvě. Slyšíš mě tam? Docela dobře, nebo jak? Jedna, dvě. No.
Broadway theaters and things like that.
I'm not Lady Gaga, and I don't play her on TV, just in case anybody's asking, although it certainly feels odd to have this microphone on.
Okay, so good afternoon. We will continue with afternoon sessions. I'm glad that I can welcome the Norm Walsh, and he will tell you something about the current state of XPrague. We already had a lot of XPrague work being done at Prague, because on Tuesday and Wednesday we had XPrague meeting here, and yesterday many of you attended the XPrague. It has been afternoon, so the Norm Walsh.
Thank you very much. So yes, Jurka graciously gave us a couple of days of space for a workshop, and in return asked me if I would speak a little bit about what we did, and because I don't say no, I said yes. So I'm going to talk a little bit about where we are and what we've done recently and where I think we're going. So for those of you who don't know, XProc is an XML pipeline language. It became a recommendation in 2010 from the W3C, but last year W3C closed the working group down. I mean, the working group had dwindled to too few participants to legitimately assert that we were going to get to rec anyway, so I'm not heartbroken about that. I'm just, that's what happened. But there's still a small and active community, and there are at least 2 active implementers. Possibly there's more. Akim was here before. I'm sure there he is. Has Morgana, and I have XML Calabash. So we've still got implementers interested. We've still got people interested in writing pipelines. And yesterday, as Jyrka just mentioned, Akim and Garrett organized a 3-hour session, 2 back-to-back 90-minute sessions in the afternoon, to sort of let people demonstrate the cool pipelines they'd done. And I was just gobsmacked. There's all sorts of really interesting pipelines, big pipelines, people doing really interesting and complicated things with pipelines. And we filled a room for 3 hours, and nobody left in the middle bored to tears. So I think there's a lot of reason to think that, that we've still got the ability to move this forward. So, I mean, what you could say about XProc 1.0 is it works and it's good and it's nice, but there are some places where it could conceivably be improved, and there are some places where there are some usability issues, and so we'd like to address those. We still have a W3C community group, but we don't have a working group anymore, so this is a life after a standards org reality. Last year, I forget who suggested it, but it was suggested that we have a workshop last year, and so we turned up. CWI and Stephen, who's around somewhere, or was around somewhere, there he is, gave us a room, and about a dozen people showed up and spent the whole day talking about it, and we came out of there energized with some good ideas, and we actually, a bunch of us completed some of the action items that came out of that meeting, which has to be a good sign. And then we talked about the possibility of having another workshop here, and so I said, well, yeah, we could meet for another day before XML Prague, and somebody said, a day? We need 2 days. Okay. And we filled 2 days. We had at least a day and 3/4. And again, we made some good progress. We got some folks to sign up to be editors. We got some folks signed up to work on documentation, to work on a test suite, to curate some new steps. So we have specific volunteers signed up to do things. We've agreed to report monthly on the XProc Dev mailing list, so we'll be able to see that we're doing work, and we have periodic reminders to get the work done that we've promised to do, which is useful. What you probably really care about, does that fit on one slide? Kind of. What you probably really care about is what are we going to do? Well, we're going to do XProc 3.0. That's what we've decided to name it, in the spirit of skipping 2, because everybody does. In fact, in the spirit of skipping 2, because the working group before it disbanded fiddled about with the idea of a 1.1 and then fiddled about with an idea of a 2. So 3 is a clean start, and we're going to base it on the 3.1 data model and XPath and such. So being in the same 3 family seems like a good idea. Going all the way to 3.1 seemed a little goofy, so we didn't do that. It's going to be an XML syntax that will be familiar to people already familiar with the 1.0 syntax. I don't think anybody's promising complete backwards compatibility. We're trying to fix some things after all. Before the working group disbanded, we fiddled with and made some commitments to a completely new language, one probably not based on XML. And the group of volunteers that we have now think that's too big a break. I'm inclined to agree. So we're going to do something in XML. And then I'm not going to read the rest of these bullet points. These are some of the things that we think are important to do in vNext, some of the deficiencies that we would like to work around, and some new capabilities that we'd like to add, along with, not on this list, a bunch of new steps potentially, and a bunch of syntactic shortcuts. The working group in the 1.0 time frame, I mean, 1.0 was an interesting struggle. It took a lot longer than we thought it was going to, and working groups eventually get to a point where getting finished is the most important thing. And so there were some obvious opportunities for syntactic improvements at the last minute, and at the last minute the working group said, no, we're not changing anything we don't have to change. But I think with a few years of use under our belt, there's some obvious improvements we can do, so we'll do that. Is there anything else on this slide? I don't think so. Yeah, there is, but you can't see it because I'm dragging the wrong scroll bar. You know what? It's not important. I'll put the slides up somewhere. I'm almost finished. There was no way I was going to fill 30 minutes, so I hope there's lots of questions, or maybe somebody wants to do something else for 10 minutes. You can all think about your demo jam things and bring them up to me. So the minutes of the first workshop are there. The minutes of the second workshop are also up. And if you're interested in following along, the XProc Dev mailing list is where we're going to report on our status and work on stuff. If it turns out that our mumblings about new specs and implementations on the XProc Dev mailing list become distracting and the community of XProc users grows to the point where they're annoyed about that, then we'll think about splitting it out. But for the moment, it seems good to keep everybody focused in one place. I think that's all I've got. Yep, that's all I've got. So thank you very much. I'm happy to do questions or get the heck out of the way, whichever you'd prefer.
Thank you, Norm. That was quick, so we have plenty of time for questions. So Stephen, over there. I will try to remember the queue.
So I have two questions. So why don't you tell us something about what the differences are in the new XProc? I mean...
well, I mean, this slide attempts to elucidate some of those differences. I'm happy to talk more about it. I just hate reading off of slides.
Yeah, but I mean, you've got the time, right?
Okay, sure. So let me talk about some of the things in 1.0 that are restrictive and we would like to remove. In 1.0, variables and options are required to be strings. A lot of the, well, when we started 1.0, we thought we might be finished before XPath 2.0 and XSLT 2.0, and so there was a small minority, but a significant minority of the working group that was determined that it should be possible to implement on XPath 1.0. And so we didn't want to deal with data model issues in two different versions, so we insisted they be strings. I think that was a mistake. Everybody thinks that was a mistake. So variables will be allowed to contain any XDM instance you'd like. So you'll be able to pass subtrees around, you'll be able to pass maps around. The motivation for going to XPath 3.1 is to have maps and arrays, because parameter ports are just ridiculous nightmare in the language. They're very complicated. They deal with a particular, so the particular use case that forced parameter ports into existence was the ability to pass parameters from an XProc pipeline into a style sheet being run in the pipeline. Think about the DocBook style sheets. They've got, I don't know, a couple of hundred possible parameters. If somebody sticks a call to the DocBook style sheets in a pipeline, they have to either enumerate all 200 of those options so that you can possibly set them from the outside, or you're not able to set them from the outside, or we need some mechanism by which we can transparently allow things to slide through. And that's what parameter ports were for. We didn't have maps, so we didn't really have a better solution. At least the working group couldn't come up with a better solution. But in practice, they're complicated and they confuse people, and just saying that parameters are going to go in as a map and maybe some rules about how to get default parameters into the map is a possibility. The other big constraint that, see, now I'm going to go longer than half an hour, it's your fault. The other big constraint that 1.0 introduced in an effort to be simple and to be focused and to not add new issues was what flows through the pipeline in 1.0 are XML documents. So if a text document comes out of a style sheet, you lose. If you try and pass in something that isn't XML, you lose. In fact, there's a little bit of creativity in the implementer community around that, but that's the rules in the spec. And that doesn't fly in the real world. That was too restrictive. We're going to allow any kind of document you want to flow through the pipeline. We're going to treat JSON as a native data type because the XPath 3.1 data model now supports JSON objects in the forms of maps and arrays, so we'll be able to do those natively. But we're also going to let images and other things flow through. So we're going to provide media types on all the objects, on all the documents that are flowing through the pipeline. And if we're going to have media types, then we're also going to allow you to do arbitrary metadata. So you'll be able to associate metadata with the document as the document flows through the pipeline, and then make choices and make decisions and make process things differently based on what those what those properties are. Attribute value templates are an obvious extension. The syntax of the language allows you to use attributes to do shortcut option references, but in 1.0, those are literal strings. Making those ABTs is a no-brainer. Similarly, we invented a step called ptemplate that lets you do a kind of text value template. It lets you use parameters to do interpolation of variables inside element content, inside text content. It seems obvious post XSLT3 to allow text value templates as well, to allow those curly brace substitutions in the language itself rather than having to have a particular step for that purpose. The other thing that lots of people have asked for is the ability to import functions, user-defined functions. And I spec'd out doing this, importing XQuery modules or importing XSLT style sheets that contain XSL functions, and then letting you call those functions from XPath expressions within an XProc pipeline. I think that's pretty straightforward. Whether we need other mechanisms for doing that is an open question. Whether we need to do schema import is an open question in my mind. If you want to refer to my hat size in an XPath expression in a pipeline, you're going to need to have a definition of my hat size, which means you need to import a schema. I don't know if we'll go that far or not. All right, I'll scroll down so you can see the rest of these. You've persuaded me, Stephen. Except that I can't find the cursor. Where is the cursor? There's the cursor. Right, import functions. And then everybody wants a standard eval step. The technical challenge in an eval step is that at the moment, the number and name of input ports and the number and name of output ports are fixed in the step declaration. So the XSLT step has two inputs, a style sheet and a document, and two outputs, a primary result and a secondary result. But if you have a step that evaluates pipelines, then the number and nature of the output ports is going to depend on the pipeline you're evaluating. I don't know how we'll deal with that, but we'll come up with something. Lots, as I said, and then lots of sort of syntactic sugar, ways of reducing the verbosity of pipelines by allowing attributes to percolate up a little bit and stuff. Those are the ones I can think of off the top of my head, Stephen.
Yeah, thank you.
You had two questions.
Yeah, and I see a related one there on the Twitter, but this is my point. One of the motivations behind Invisible XML is to allow you to have two isomorphic versions of the same language, one textual and one in XML, and it wouldn't be out of the question to just have that definition, and then people could choose whether to do it in XML or whether to do it in text, but you still end up with XML.
Yes. So if you think about having a non-XML language, then you have to decide: is it a requirement of the language that every non-XML syntax version can be translated into an equivalent XML version and vice versa? RelaxNG achieves this with the compact syntax reasonably well. Attempts by small groups of us at various times to invent a non-XML syntax with that property were not fruitful. The alternative is to say, no, they don't have to be, you can just do one or the other. So I'm going to step over here, put my implementer hat on. In the rewrite I'm doing of XML Calabash, I have broken the entire process into two pieces. I have a core pipeline engine that knows nothing of the surface syntax. You construct the pipeline with an API, you pour documents in it, you push the go button, stuff falls out the bottom. How you got that abstract, how you chose to drive the API to build that graph to run that pipeline. Yeah. So, and my example for that is I have a little pipeline that you handed an arithmetic expression, and it builds the parse tree for the arithmetic expression and runs it as a pipeline, and answers fall out the bottom. So you can add 3 plus 4 times 2 times 7, and you get whatever that is out the bottom. Once that's in place, writing a parser that takes the XML syntax and builds the appropriate pipeline for that is straightforward. Deciding that I want some other little language that happens to not quite be XProc but also builds those pipelines is a completely reasonable thing to do, and I will probably poke and needle at that at various points along the way.
Okay, I think that next was John to ask some question. No? And there was someone over there to start.
This is probably a stupid question, but how can you make a 3.0 when the working group is dead?
Well, the group of us, under the auspices of the W3C community group, we're going to do some stuff. And I mean, at the last minute, if we end up never reconstituting a working group, and a bunch of volunteers, and Akim and I, and maybe somebody else come up with some compatible implementations that pass the test suite, and the W3C comes along and says, you can't use the name XProc, we'll just rename the damn thing. We talked about changing the name, but there's no point confusing the community by trying to make everybody learn a new name. Everybody knows what XProc is. I don't anticipate that happening, but I'm not going to worry about that until we've actually achieved something technically.
Okay, any more questions? I don't see any hands, but I have one question which is not related to XProcs. Do we still have 3 slots for Demo Jam?
We do have a few slots left. A couple more people have handed me paper, so I'm not sure quite how many, but there's at least a few left. And all right, several people have suggested that my requirement that you scratch graphite or biological material onto a pressed dead tree and hand it to me is an onerous requirement. So if you want to send it to me in email or tweet it at me, that's fine, with the proviso that I take no responsibility for delivery of the message. The most reliable thing to do is hand it to me, but I will try to keep an eye on my email and on Twitter if pressing dead trees and scribbling on them with ink is too burdensome.
Okay, thank you. We have some paper and pens on registration desk if someone doesn't have such old-style facility with them.
And please write neatly and legibly, please, just if you want your name spelled correctly. And Stefan Han, somebody, I have a question about the accents on one letter in your name, so come find me at some point.
Okay, thank you very much again.
Thank you all very much. Yeah.
I'll just mute it, so
okay.
Now it should not be doing any sketches.
That's a nice mic.
Yeah. So now we will have to improvise a little bit because the next speaker lost his voice over the night. Yeah, but we are prepared for everything during the XML conference. So the next talk should be delivered by David Philip, but he cannot speak, or at least speak too much loud. But he had some colleagues and friends here, so the presentation will be delivered by Jan Husar and Husarchik, and Sourosh Sadafar. So please come here and join us. I will give you some devices.
So I'm giving you 3 speakers in one. Sorry.
Does it work? Obviously.
I think
Yeah.
Okay, and you will learn something new about the current status of XLive, which is the localization standard and how it integrates with ITS. So we start.
Thank you. Hi, everyone. We have to say that the presentation was reassigned to Jan and myself just today after lunch. So we were supposed to have an easy day, but it didn't turn out like this. So David and myself are co-editors of XLive 2.1. And Jano is our industry partner, a stakeholder from Moravia, so he would start the presentation, and then I will come in at the second part. Here we go.
Just present, you should use keyboard probably.
Okay.
It's just laying on the table.
Okay, so as Surush said, this was a bit unexpected for me, so I might not deliver the best performance. What's XLive? XLive is XML localization interchange file format and the only open standard bytext format available. The previous version, 1.2, was a standard since 2008 and was replaced or superseded by the current version 2.0, which is not backward compatible with the previous version, but the reason for this is the modularity of the standard, which will allow all the following versions to be backward compatible with 2.0. The first public review, the first draft for public review was published last year. The public review was completed, and now the second one is open for your contribution. Since today, you can find it on OS's pages. Well, I already talked about this. The main changes in the first release is the ITS module, and which we'll sort of talk about, and major bug fix of change tracking module. So this is the agenda, and what's btext? Btext is basically aligned pairs of source and translated sentences, which in case of XLIF is ordered by default, ordered as, for example, sentences in this slide. That's different compared to, for example, TMX or TBX standards, which are just unordered artifacts which serve for translation memory exchange and terminology exchange. This is a sample bytext where you can see original text in English and the translation in Czech of the poem by William Blake, where this version is a tabular layout, usually presented to translators for easier navigation. In XML, you can start by aligning the text using the nodes depicting the source and translation, compared to, for example, PO, where the only thing are pairs of ID, which is also the original content and the translation. Well, this is basically the final PO file. In XML, you can add additional metadata in form of attribute, in this case, describing the original and translation target language. And by grouping the bytext into segments and into units that, in this case, correspond to the paragraph from the poem. Stanza. So bytext management is basically what I do as a localization service provider. It's a group of processes that manipulate these ordered or unordered bytext artifacts. By manipulation, we mean the pre-processing, the translation, review of the translation, QA. In case of unordered bytext, it's the translation memory and terminology management. This flowchart represents how XLIF serves as a way of communication between various agents in the localization workflow, usually starting with XLIF being extracted from the original format, where basically anything can be extracted to XLIF, where recycling is applied, machine translation is applied, the actual translation is carried on, quality control is performed, and then is delivered back to the CMS or the customer. This is the most simple use case where both customer and localization service provider don't support bittext. You can imagine a translator that gets his Word document in, for example, English, open another Word, and just types the translation into the second document. You cannot really automate this workflow. You cannot make use of all the features the localization industry offers. And we are getting to the other use case where the customer is aware of what localization can do for them, but outsources all the management, all the bytext management to the LSP, where the extraction, the rest of the localization workflow, and the merging is done on the LSP side. And final example, the corporation has its own bytext management system where extraction and merging is done, which is currently being quite common. And just the translation editing and quality control is left to the LSP. These are the various scenarios you can end up with standards. The ideal solution is when the standard is where the communication is based on open source and open standards. Then you are getting to various combinations with the worst case scenario where the standard is proprietary and the source is closed. And you are basically dependent on the LSP without option to choose or change it as you want to. Again, on the open side, the process of the standard, of creation of the standard is transparent and is royalty-free, as is the case of XLeaf, where you can actually contribute to the standard via the mailing list. And on the other hand, the whole standard is proprietary and you can end up paying for the implementation. The bytext evolved from the RTF, it's called unclean RTF, where both the original content and the translation is stored using some extensions. Then there was the XML-based proprietary format. Maybe some of you know the TTX in Trados. In parallel, the PO-getText was created, but as we've seen, it's not usually enough to convey all the metadata needed for the localization workflow, where XLeaf 1.2, well, 1 comes into play, which evolved into current implementation. If you take away the X from the XLeaf, you get just the localization interchange file format. The committee is working on the object model that will allow for example, JSON serialization of this standard. And Surush.
Okay, so for the XLeaf standard defines agents because the XLeaf is supposed to be used in the life cycle of the whole localization process. So we have these sort of agents we have defined. We have different behavior and compliance regulations defined for all of them. So we have, like you can see the whole process of work, the localization project coming. So you have the writer, which extracts and reads, modifies, and merges back to the original format where it was taken from. So that is the innermost block of XLIF. So we have these inline codes that can appear in line with the text. So it's pretty much like the textbook, the docbook inline elements. So it's a lot of them, but most important things, you can see the recursivity of PC, which is for paired code. So if you want to replace HTML codes, you can have all of these inline elements again here. And the same for markers, so you can have the different nodes linked to the span of the text. But the most interesting ones are the pair of SC and EC for start code and end code. These are implemented in XLIF so they can replace the non-well-formed tags. So like in RTF, you can have the one tag open, the second tag open, and then the first tag closed. So you cannot have this behavior in XML. That's why we had to embed those two elements so they through attributes to refer to each other. So you can have the span well-formed in XML. The same thing is for SM and EM, so these are for markers, for nodes, and those SC and EC are for code. But as this paper is mostly about ITS, and it's, so the standard is implemented within the core and several modules, and so ITS has been, it's for internationalization taxes, so it's, I will get into the ITS a bit later. So it's the current status of XLIF. So we see that we have a lot of modules here, but for the latest version that has been just released for the second public review today, we have ITS module added, and we have the change tracking module also reinvented because we had the requirement from implementers from the industry that people need to be able to track more elements. And so these are the data categories that ITS defines. So you can have pretty much everything that you would need to mark up. You would need to have different metadata for enrichment of your content to be internationalized and then to be localized in the process. So you can see that they all perfectly map all the 19 data categories of ITS. They're being implemented in one or another way in XLIF, and so you can see the kind of historical background of the, for terminology, you have the standard like TBX. You have TMX for memory, for translation memory exchanges, and it's like the Dublin core. So you can see these, probably these would be more familiar. So you can see that they have been all mapped into XLIF and ITS, so they represent the data categories. And so ITS, the basic idea of ITS is to be easily injected into other vocabularies. It has been also adopted by HTML, so you can have your HTML files already enriched with ITS metadata. So if we look at this HTML file here, so this is the very basic, the most basic data category of ITS. So you can have translate, which is actually implemented in HTML locally. So this one is easy. The next one, so you can see that ITS has rules that ITS translate knows, so you can have the span of the text that you don't want to translate. You can also apply the rules globally. So if you put this at the start of your document, you're saying that I don't want to translate any code element inside the whole document. And over here are XPath expressions, so you can access pretty much everything inside your file. And so how, for instance, this one, the translate data category is implemented in XLIF, already been there because it's apparently a very important feature in localization. So we have our own translate attribute, so it can be applied to a whole unit, which is the biggest block of the stored text, or you can have it in segment as well. Yeah? No? Okay, sorry. So segments are supposed to be translated all the time. So if we look at the equivalent in HTML, it has been extracted into XLIF as such. So you have the first unit that is going to be translatable text, and the second one is not going to be translated. And there is also another way, so you can actually completely ignore the non-translatable text and just not extract it because it's not going to be translated or localized anyway. Yeah, so you just take the translatable text. So if you want to look at the kind of classification of ITS data categories from the point of view of how and when in the localization project is they're being used. So the first one is on the extraction level. So you have the translate local filter, which you can filter some local. So if you're going for a certain country or local, you can just exclude that from your list. And when your text is mixed with other elements, but there are data categories that represent the localization behavior. So pretty much they're all straightforward. Their name suggests the functionality. But the interesting one here is the target pointer, the second one. So using that, you can actually map your original content to various translations. So you can have the multilingual the multilingual corpus of your data. It can be used to create translation memories, to train machine translation engines, and anything else here. Well, the rest of them are pretty much straightforward. So. And then we have the next class is the subject matter data category. So you can again have your terminology, text analysis, or the domain of your content. So what there is this class is being produced during the project. So you have your machine translation confidence. You can have different sorts of rating, quality assisting, and also tracking the provenance of the whole project. So if we go to see how ITS and XLIF, how ITS is being implemented in XLIF now, so we know that we have already a lot of them inside XLIF. So translates, you can store localization notes in the XLIF. But we had some data categories that had to be implemented from the scratch. So these are the allowed characters and text analysis. So they were not represented in XLIF at all. We have another bunch of data categories that have partial overlap, so they need to be mapped and be given the recommendations to be used properly for XLIF. And we have some data categories that are not represented, but they are completely consumed during the process of extraction. So when we were working on integrating ITS into XLIF 2 as a module, so we were first going with that namespace. So it is the OSIS namespace for XLIF documents. So we're going to have the ITS module, but because ITS processors would not be able to track this namespace and the actual ITS information, so we had to actually use the original W3C namespace, but still because we had that issue with not well-informed elements, so we had to actually have the ITSM also for two data categories, which are language information. This, as it was mentioned, is being bytext all the time. So you can, if you want to add your third language or fourth language, you would need new attributes. So that's why we decided to use the ITSM and ITS namespaces as well. And yeah, so if you see the actual usage of SM and EM, as I mentioned earlier, so if an ITS processor would just point to this to these elements, what they get is not span of text, but is just empty, because that is standalone element. This is standalone element. It is kind of pseudo span. It's not the real span. So it's so it is the so this is one of the XLIF specific features for overcoming this limitation of XML. And so we had the, sorry, I didn't get this one. Yeah, so we don't have the ITS for the global pointer, so we had to do that as well. And yeah, so yeah, it's still sorry. It's again about the ITS processors, how they can actually access and manipulate the data which is already inside the file. So you can sorry, for this feature of the ITS, you can have the ITS processors can actually very easily implement it to not have empty elements of SM and EM, but actually get the span of text. So it can be very easily implemented and added to the existing ones. And you don't have to implement the entire XLIF for that. You can just have this particular behavior. So we are having a release of the XLIF 2.1 right now. It's going. So if you want to subscribe or to contribute into our work, if you work with XLIF or ITS in any way, sorry, yeah, sure. Please do contribute. We are having as Jano mentioned, we are having the AMOS group, which is for object models. So XLIF was so successful, well received, and widely implemented. So we're working on an abstract model for to have the logic of XLIF as the container for localizable data. And we had a very interesting issue that Jan actually raised into our mailing group, and if you want to share your experience.
We had experience with extraction process that was using standalone tags to represent paired elements or non-empty elements from the original content. Imagine HTML with bold tags, which are represented by standalone tags, PH, that have a completely different purpose in the XLIF. So we raised an issue via mailing list and asked to provide additional clarification in the standard that will explicitly disallow this use of the PH element.
Thank you. So please, if you have any questions, David or myself would be happy.
So thank you guys. Thank you for helping Philip. So are there any questions? Do you see some hands? Because yeah. Wait for another mic.
You shortly showed this example of a unit with the ITS translation.
So that's the other option, how to extract it. It's pretty much the decision of the extractor merger tool. The corporations usually implement the extractor merger tools, and it's pretty much up to them. They own the extraction merge bracket, if you want, of the process. But you can't answer this once for all. It depends whether there is linguistic relationships between them, because if there is linguistic relationships, it's important to display it to the translator. And the target element, that's the first part of the question. The target element is optional. There is 0 or 1 target elements. But there is a state attribute that can be used on segments. And then if the segments are considered more advanced than initial, then the target must be there. So it doesn't matter that it's the same if the whole thing is non-translatable. There might be differences in normalization, whatever, or it might not be. It is important. Almost always, it's important to display it, and in some cases, it's also important to create a target even if it's not translated. I hope this. And yeah, there is a specialized element. We were not going into this right now. There is a sibling element to segment called ignorable, which is a special kind of segment that basically doesn't contain anything translatable and also doesn't require a target because it just contains, some white spaces or control characters or whatever. And those control characters would be encoded using the CP, like in LDML.
The reason you want to put non-translatable text inside XLIF is to provide context. For example, a translator is working on some text which references code examples. But he would like to see those code examples, for example, because of the variable names. So he correctly places them and uses them in the translation. And about the missing target, we actually raised an issue via the mailing list about how merger should proceed in case the target is missing.
So do we have more questions? Because I don't see anyone. Maybe yesterday you also had some presentation about how to utilize XLIF in Oxygen. So maybe once the videos are ready from Oxygen users meeting, if you are interested to learn more about XLIF, you can watch the video if you haven't been attending in person yesterday.
Yeah, well, thanks for Jirka to mention that there is an Oxygen framework for XLIF, and basically you can validate XLIF in Oxygen using that framework. And Suruj will actually put the latest advanced validation artifacts, the schematrons from 2.1 to this framework. So it will be very useful for actually playing with XLIF 2.1 and 2.0. Thanks.
Okay, so thank you again. So now there will be coffee break, so we'll be able to enjoy coffee, and David will be enjoying Vincentka, the special Czech mineral water, especially created for healing your voice. So upstairs there will be coffee and tea and sponsor era, and downstairs there will be something for eating, and we will continue in like 30 or 40 minutes. And also I saw some free pens in sponsor era, so if you don't have pen to apply for the Imogen slot, you can borrow or maybe even take pen over there. So enjoy the coffee break and see you in 30 minutes.
You can take it. It's from the font XML editor, I think. Actually, it's not possible because it's just for speakers for thinking because it's just it's not arrows, just located in company, just standard. And I'm really not sure if the couple of glasses are maybe I just I can try because there could be some glass shot, so something like this. Yeah, I can understand. But you know, I can try to Google for you. Because they usually just have some kind of marketing glasses which are just putting to the box. So that maybe the easiest thing is just to store it in some restaurant.
But I haven't seen it one. Have you?
You can see. It's actually not the full, it's different. It's just glass. It's just gold. Yeah. I was thinking that I can give you one and then say, okay, sorry, I just broke one. Yeah. If I would just try to remind us more crazy one for me.
Hello, Mike. So probably we should check setup. So yeah, so that everything is working properly. You can plug it here if you need electricity.
To buy another adapter.
But
I forgot to bring one.
Sorry. If I know it in advance, I can bring just this.
I just realized that Heathrow. I haven't got one with me. I have to buy it.
And I suppose this Apple accessories are quite expensive.
Oh, it's not an Apple.
It's just something around it. Oh, just around it. Actually, it's just in one piece, so you need to buy just this out of
Actually, the Apple plug is actually bad tolerance.
And do you have the adequate for VGA or HDMI?
Let's try the HDMI.
I think Apple's HDMI or Blu-ray.
Yes, the recent one too.
Not quite the aspect ratio.
They have like 3 different projectors, and this one is very old and has different aspect ratio than
Yeah, the text is readable, and you know the image is much better if you look from large distance, so don't be afraid, it should be readable.
Oh, okay. I've increased the font.
Yeah, that's cool. It's perfectly readable. Even for me, and I wear glasses. I need to sit in first 2 rows in some presentation, so otherwise I don't see much. And there is voting if you would like to use it.
I will probably need it. I'll probably lose my voice halfway through.
Okay, so there's still time, so if you would like to enjoy some coffee or whatever. Ah. So bad thing about this room, there's no clock. Yeah, and we forget to bring some make notes myself on it. If you don't have should I borrow mine? Or will you just looking on the and actually you might still some extra hyper it's fine. Okay. Fine. For free, but
switched on, is it?
yeah, it's switched on. So
okay.
People can hear you.
Do this.
So welcome back from coffee break. We will continue. If you have been attending XML Prague, you know that in past few years we had several presentations and workshops about streaming facility which will be included in XSLT 3.0. And today Mikey will tell you something about how you can, or how he approached the implementation of this functionality.
Okay, thanks very much. You probably wonder how we sort of manage we're constantly adding new things to Saxon, but occasionally when you're managing a code base that's now nearly 20 years old, you have to sort of look back at some of the old things in there and wonder what to do about them. And the background for this talk was that I have been slightly unconsciously uneasy about the fact that we've got this code in the product that's been there for 10 years to do document projection. And I was wondering whether anyone was using it and whether it was worth keeping, and also whether actually had any relationship to the work we were doing with streaming. Originally, the idea was to common things up a bit, but that never happened. So I decided to take a little bit of a review of the document projection code in Saxon and think about what to do with it. This talk results. So what is XML projection? It's actually probably the best idea that anyone ever had in the whole of the history of XML technology. And hardly anyone knows about it. It was introduced in a paper by Amélie Barrien and Jérôme Simeon, apologies for my French, at VLDB in 2003, in an XQuery context. And the basic idea is that you take a query as input, and you look at what parts of the XML document are needed to satisfy that query, and then you build the document into a tree in memory, retaining only the parts of the document that the query is actually interested in. And it turns out for a lot of simple queries, the query is only interested in a very small part of the document. And if you build only that part of the tree in memory, then you've actually got an enormous memory saving and potential for a few other little savings as well. So that's the idea, and it works very effectively in theory, according to all the examples they did in their paper. And I decided it was about time to reinvestigate how well it worked in Saxon. So here's a schematic of how it works. You take the query, you do static analysis on it, and then in the normal course of events, the static analysis produces a compiled query. But in this case, the analysis has a second output, which is that it generates what in Saxon is called a path map, which is a map of all the paths in the document that are used by the query. And that path map is then used to filter. You inject a filter in between the XML parser and the tree builder, so that the events coming out of the parser are filtered, and only the ones that are relevant are used for building the tree. And you build a subset of the tree. And then you run the compiled query against that filtered tree, and if you've got the analysis right, the query produces exactly the same answer as it would have produced against the full document. So just to illustrate that another way, here's a trivial list of books. There's a query against a list of books. And the bits in red are the bits that the query actually needs. Now that looks like it's accessing quite a lot of the document, but that's because when we draw documents on PowerPoint slides, we like to simplify them. In the real world, a book list contains an awful lot more than 4 fields: title, author, date, and ISBN. It contains a whole host of stuff about history of reviews on Amazon and you name it. Entire publishing history of the book, what editions is it available, is it in, what's the price in every different country. You're going to have, a couple of kilobytes of data about each book in a real data file of this kind, and you're still going to run that same query that only needs those red bits. And so what you find is that in that kind of environment, the amount of data you need to keep to actually answer that query is a tiny fraction of the original, possibly only 2 or 3% of the original data. And so you've got an alternative to streaming. Instead of executing the query in streamed mode to save memory, you've got the option of stripping down the document to its bare essentials and only retaining the bits you need in order to save memory. In Saxon, document projection has been available since Saxon 9.0, in other words, pretty well since prehistory. It works in XQuery only, and there's a reason for that, and that's it's very hard to do this kind of static analysis in XSLT to work out which parts of the document are reachable. I was reminded this morning, in fact, I'd completely forgotten that when I put the path analysis into Saxon, it wasn't just motivated by doing document projection. It was also motivated by a project I was doing with Eric Boucher on Orbion. I don't think he calls it Orbion, he calls it Orbion, on the XForms product. And what you need for XForms is the ability to analyze which parts of a document are reached by each of the XPath rules in the XForms model, so that you know if there's been a change to the input, which rules do you need to evaluate. And so that's similar to the sort of schematron thing we were seeing this morning with dynamic re-evaluation of rules. If you can work out which rules are affected by which changes to a document, then you can work out which needs to be re-evaluated. And that path analysis of basically reachability analysis, which parts of the document are accessed by an XPath expression, turned out to be very much the same analysis as is needed for document projection. So it's not widely used, and I know it's not widely used because I tried it a few weeks ago and I found it didn't work. At least, you know, we've got half a dozen tests that we've been running every release for 10 years, and those tests work. But when you try and do something other than those tests, you quickly find it's broken. And one of the main reasons it's broken is that it hasn't been updated for the 3.0 specs. So we just aren't doing all the path analysis for a lot of the new constructs. So that's pretty good evidence that no one's using it, which is a shame, because I hope to show it's actually quite a powerful technique. And when we started doing the streaming work, I had good hopes that the path analysis used for document projection would have a lot in common with the analysis you need to do for streaming. In fact, I think it inspired a lot of the analysis that went into the spec, but it ended up being sufficiently different that the actual logic in the code is completely different. Let's take a little look at it working in practice. You don't want to see more slides. So here's a query from the XMark benchmark. The original VLDB paper uses the XMark benchmark queries and shows their effect on projection. It's written the way all the XMark queries are, as a flower expression. I think most people nowadays would write it as an XPath expression. But it's saying for, I won't go into what the actual data structure is. It's actually quite complex. But it's saying, find all the persons with that particular ID and return their name. And I'm running this against the 100 megabyte version of the XMark database. And I'm running each query 10 times to get decent repeatable performance numbers. And if we run that on 100 megabytes of input, let's take a little bit of a look at that. So we're building, first of all, we're analyzing the query, and it's going to say somewhere what the analysis time is there. That's not a very meaningful number because it's actually dominated by Java VM warm-up time. It's probably really more like sort of 250 or 300 milliseconds just to parse and compile that query, which seems an awful lot. We are then building the tree. This is running without document projection or streaming or anything. We're then building the tree, which is taking 1.4 seconds. And we're then running the query. And we're running it repeatedly. And the first time we run it, it actually takes 48 milliseconds. And then on subsequent runs, it takes about 0.1 milliseconds. Now, I had a sort of panic this morning. I thought, surely it can't really be running in 0.1 milliseconds, searching 100 megabytes of data. And I had an inspiration and realized that actually this method of running the query repeatedly, we encourage people to do it to get repeatable numbers and to discount the effect of warm-up time in the Java VM. But actually, it's having another completely spurious effect in this case. So these numbers are a complete cheat. What's happening is that the first time you run the query, the optimizer has said, that's a handy thing to have an index for. And so the first time you run the query, it builds an index on people by ID. And that's what's taking 50 milliseconds. And then all the subsequent queries, it just looks up that index, and that's what's taking 0.1 milliseconds. So it's not actually searching 100 megabytes in that time. It's actually just looking up the index that it built the first time round. This is why performance is so magic. There are just so many ways of getting wrong numbers and of being deceived by your own figures into thinking that you've proved something that you haven't. But it's still not bad. 50 milliseconds still is the actual execution time for the query is vastly faster than the time for building the tree. It's even faster than the time for compiling and analyzing the query. So this kind of thing shows that actually an awful lot of the work we've done in the last 10 years to make queries go as fast as possible, is actually wasted effort in some scenarios, and in particular in the effort where you're compiling the query every time you run it. We're putting an awful lot of effort in at compile time to make the runtime faster in ways which even against 100 megabytes is actually not justified. So that's it run without projection. If I run, I'll just pin that so we can look back at it and run it now with projection. So all we have to do is add the option minus projection, remembering that it's possible to type on a keyboard when you're standing up. So one thing you never practice, isn't it? You know, when you're doing a presentation, what's it going to be like if I'm standing? Okay, so that's run again. The analysis time is still, 400 and something milliseconds. It's giving some feedback on the use of document projection, and it's reporting a 98% reduction in the number of nodes in the tree that it's had to retain. So what that means in practice is that if you had a limit of, let's say, 1 gigabyte on the size of document you can practically process without streaming or projection, then projection has a good chance of raising that limit by a factor of 100. So you might not even need streaming to get the memory reduction that you need to fit this query into memory. The the tree building time is reduced a bit. You remember it was sort of 1.4 seconds before, it's now 1.0. The parsing time is exactly the same. I think this 100 megabyte document takes about, it would take about 900 milliseconds just to parse it and do nothing else. By the time you add some tree building at the back of the parser, it takes a bit longer. And what's happening is by building less of a tree, we're saving some of the work. And so that's cutting the tree building time from 1.4 to 1.0. And that's actually the biggest effect on runtime here, is that it's reducing the tree building cost. The execution time of the query is much the same, a little bit faster, from 50 milliseconds down to 4 to 6. And again, these numbers are just using the index, which, as before, is pretty spurious. So that's projection in practice. And it works on all the queries in the XMark benchmark. And actually, most of them, it is achieving a reduction of about that amount, a reduction to better than 95% in the size of the data that's needed to run the query. So benefits of document projection: you don't need to change the query at all. There are none of these sort of streamability rules that say you can't have multiple downward selections and you can't have joins and you can't have reordering. You can use any query that you like. the more complex the query becomes and the more of the data that it accesses, the less the benefits will be. But it's very incremental. There's no sort of cut-off point where you can say, for this query, it's just not worth doing. So it's quite a soft and adaptable technology in that sense compared with streaming. And the potentials for memory savings are quite extensive. What are the limitations? Some of them are the same as the limitations for streaming, which is that it only applies to single-shot queries. If you want to use the document in memory for more than one thing, then you're out of luck, because this is very much customizing the in-memory representation to one query. The one reservation for that is that if you want to do the same query lots of times with different parameters, then streaming doesn't help you, but projection does. Because the projection rules are the same regardless what the values of the parameters are. So the projected document can be used to answer the same query with different parameter values. There are things that you can't statically analyze, especially lots of things in 3.0. Dynamic function calls, any kind of eval. You can't apply this to XSLT because of template rules, which mean you can't do the reachability analysis. So it's not easily going to apply outside that domain of fairly simple X-query execution. So this is just a slide giving that information. So 50 milliseconds isn't bad, but it's not quite as good as I thought. I don't know if the wrong figure found its way into the paper. It might well have done. So looking at the queries across the whole, I already mentioned that 19 of the queries achieve memory reduction of 95% or better. The results Saxon is achieving are very consistent with the ones that Marianne and Simeon reported. The query analysis cost is not measurable. There's no measurable extra cost on the query compilation time. Tree building time about 25% better. Query execution time a very small amount better, but that's not why you do it. So let's compare and contrast that with streaming technology. Streaming is defined in the XSLT 3.0 candidate recommendation of last Tuesday. Hooray. But in Saxon, there's also a subset of streaming capability available in XQuery, either through an extension function called Saxon Stream or through a -stream option on the XQuery command line. And that just rides on the back of all the streaming work in XSLT. And I'm going to be showing a few query examples just so that we can compare them with document projection. Let's look at the one we've been looking at with streaming. And I will do a deliberate mistake here, first of all. So let's run that query with -stream and see what happens. And it says streaming is not possible. The expression bound to the variable $b is not grounded. And is not grounded basically means the value of the variable contains a streamed node. And one of the rules of streaming is that you can't bind streamed nodes to variables. So it's telling you no luck on that one. Can't do it. But fortunately, there's a very simple change you can make to the query, which is to write it the way any sane person would have written it in the first place, as an XPath expression. And if we change to do it that way, I'm running it 10 times, remember, and this time it's actually processing the whole file 10 times, because that's the nature of streaming. So Analysis time, not very different from what we had before, no reason why it should be. And it's now processing the query in streamed mode, and the execution time, it starts off at 1.6, and then after I've run it a few times, it drops to about 850 milliseconds. So basically, the execution time for the query is dropping to essentially the parse time of the file. The time is dominated by the XML parser time of actually parsing the input. The query execution adds only a negligible amount to that. This is 100 megabytes of input, and we can see that the memory usage is well down. Obviously, it's variable. It's depending on what the garbage collector is doing at the time. But it's running in a few tens of megabytes because it's basically not got any space allocated to the document tree. That compares with putting a full 100 megabyte in tree, which is going to take 500 megabytes of memory to hold the internal tree representation. So the streaming is working there. What's the difference? Answer is we had to modify the query. We can't stream any query. We have to stick to certain rules. Sometimes the changes are more extensive than that. For example, here's one of the queries in XMark, that's Q4. That's looking at all the open auctions and saying if person 18829 was a bidder in that auction earlier than person 10487, the double left arrow there is a test for whether two nodes are in document order. So this is testing whether both those nodes exist and are in that order among the siblings of the person ref elements. Well, that's not streamable because you're making two downward selections. If I try to run that query in streaming mode, then I get this kind of error message. And really, giving people decent error messages for streaming is really one of the tough challenges. Because the rules in the spec are so complex, you can't expect people to actually understand the rules in the spec. They are dreadful. But yet, at the same time, you want to give information that can be a little bit related to the way the spec describes the constraints. So I've tried quite hard to make the rules understandable by mere mortals, but yet at the same time comprehensible in terms of the rules of the spec to people who know a little bit more about what those rules are. So tell me if you think I've done a good job, and I'll try and improve it. But what it says is there's more than one consuming operand. This is what they are, the two bidder expressions on line 5 and 6. So you're not allowed more than one consuming operand. That means the predicate isn't motionless. And in addition, the expression bound to variable b is not grounded, so there's another reason it's not streamable. So when you fix those problems, again, it turns out to be quite easy to fix them. You can end up with an expression like this. And it's done the magic fix for all such problems, which is to use copy of. What copy of does is it takes a streamed node in the input and says, at this point, I'm going to materialize the tree underneath that. And so you've got to allocate memory explicitly to that subtree. So it's allocating memory to the subtree under every open auction element. And once you've materialized that subtree, you can then do arbitrary navigation within that subtree, and you're then unconstrained as to what kind of code you can write. So it's a general fix for a vast majority of streaming problems. Of course, it only works if the subtree under an open auction is small enough to fit within the amount of memory that you've got. Because what it's going to do is to populate that subtree for one open auction, and then when you get to the next one, it's going to garbage collect that and use memory for the next one, and so on. It's sometimes called burst mode streaming, where you sort of build one subtree, process it, then you throw it away and build the next one, and so on, moving through the tree in bursts. So this one will stream. We won't bother with the repeat this time. So there it is. So it runs in streaming mode. I've shown the same queries running with streaming and projection. Let's compare them a little bit. Whoops, what have I done? How does streaming work? Like document projection, we start with static analysis. So we have to do some analysis of the code and work out whether it's streamable or not. If it is streamable, then you're not going to build a source tree. You're going to execute the XQuery or XSLT or whatever it is directly on the data coming from the parser of a stream of events. And that's only possible in layman's terms. In intuitive terms, it's only possible if you process the data in exactly the order that it arrives. So if your query is somehow sort of isomorphic, if the data it accesses is isomorphic with the data that's coming, the stream of events coming from the parser, then it turns out to be streamable, and if it's not, which means if you're doing joins or sorting or anything like that, then it's not going to be streamable. If you find that the data isn't streamable, then really there's two strategies you can adopt. You can fall back to non-streamed processing, or you can reject the query. And Saxon's got sort of modes of operation where you can choose either of those options. So streaming in Saxon's been developing over quite a series of releases, as the XSLT spec in particular has developed. And I spoke here, I think it's 3 years ago now, about the internals of the implementation, which does everything in push mode. So events are coming from the parser in push mode. Here's the parser pushing the events along the pipeline. If you're schema aware, you've then got a push mode validator, which is validating a stream of events in push mode. And what push mode means is that the supplier of data is invoking the consumer. So if I'm the parser, I'm telling you when data is available, and you are then reacting to that data becoming available. Whereas pull mode says the consumer of data is in control and tells the supplier of data, give me some more. So this is supply-driven rather than demand-driven. The streaming XPath engine pushes the events along to the transformation engine, the XSLT. There can be another validation path out here. And finally, you push events to the result tree. And the result tree itself isn't a tree. It's bypassed. The result events are pushed directly to the serializer, which outputs them as lexical XML. So that's the architecture of the streaming code in Saxon. So what we find when we do all the XMark queries, firstly, we need to rewrite the queries to make them streamable. When we do that, 14 out of the 20 queries turn out to be streamable. 5 of them aren't streamable because they use joins, and joins intrinsically sort of navigate all over the input data and therefore can't be streamed. 1 of them isn't streamable because it uses sorting. And the query execution time is typically around 900 milliseconds, and that's basically the time taken to parse 100 megabytes of data. Before we look at this comparison chart, let's just look at another example, if we can, quickly. This time is data that really needs to be streamed. So I've got a file of addresses here, and this is 2.6 gigabytes. So processing 2.6 gigabytes gets a little bit difficult. If you try to process it raw, this is what's going to happen. Yeah, let's just do that query there. .6 gigabytes, remember, this time. And we run out of steam. Or rather, we run out of heap space. So I'm sure you've all seen that at some stage in your careers. Just too big to handle in heap space. To handle 2.6 gigabytes of source data in the full tree representation would need sort of, I reckon, rule of thumb 5 times, 12.5 gigabytes of heap space in the Java VM. We're starting to hit problems about the actual 2 gigabyte addressing limit in strings and arrays in Java. I don't know who's going to solve that problem for us. But it's raw heap space here. We can solve that problem by streaming. If I just add minus stream there. Right, and the first thing to notice here is that the first bit of data came out very quickly, because it's actually processing the data as it arrives. The query asked for the first record in the input, and as soon as it finds the first record, it can output it. So you're not just reducing memory, you're also reducing latency, if that's important in your application area. This should actually then early exit, but actually it's processing the whole file. And I think that's a limitation of the XQuery streaming as distinct from the XSLT streaming, but it's not quite so good as doing early exit. Because this could have decided at that point that there wasn't going to be any more data and it could stop, which means it doesn't parse the whole input file, which means that actually if there's any errors in the input file, you'll never know about them. So execution time, 27 seconds for that. That seems to be fairly typical, 10 seconds for a gigabyte seems to be the sort of rate you can expect to get when you're doing streamed processing. And again, that's basically the rate at which you're parsing the data. See if this one works with projection. Any guesses? No? Well, the answer is there's not very much it can filter out, is there? When you're doing /*/*, it needs all the data, and so it's probably going to fail in the same way. Yeah. But it turns out if we do a different query, like let's try exists // city. Then I think that one's probably going to work with projection. So we're just at the margin of what's feasible here in terms of actually fitting things within memory. The query execution time should be about the same. It'll still dominated by the parsing time, so about 30 seconds, I would expect. Yeah, so that one's worked. But what we'll see is that it used a pretty fantastic amount of memory. 1.5 gig of memory there. Despite the fact that it achieves an 89% reduction, apparently, in the number of nodes it was holding in memory. So let's sum up. If we compare the two techniques, they both rely on static reachability analysis. But there's a difference in the analysis in that on the projection side, the answer is never going to be no. The answer is going to be the level of filtration that you get on the input. That's what's going to vary, not a Boolean yes or no answer. Both of them really rely on this scenario that you're reading the document once for every query execution. So they don't work for the sort of lookup document that you read at the start of the day and then keep using for looking up exchange rates every time you do a transaction for the course of the day. It's not that kind of scenario at all. Streaming gives you constant memory, even for infinite documents. So however big the document gets, you are never going to run out of memory. You can process streams of data from satellites or from telemetry using streaming. With projection, you're getting a linear reduction in the amount of memory, but at some stage, you are still going to run out. But the big advantage of projection is that it's still very useful on non-linear queries. So queries like sorting or joins, you can still get a very, very big saving on those using document projection, so long as they're only using a small amount of the data in the file. And so that's really the big plus point. That is why we shouldn't throw out projection out of the Saxon product, because it is performing a useful service that streaming can't do in terms of a style of processing very large documents that are too big to fit in memory in a way that streaming can't actually handle. And then the other one is early exit. It didn't work as well as I would have liked on some of those examples, but there are a lot of queries, and it certainly does work in a lot of cases in XSLT, where if you can get the answer from the beginning of the file, then you can stop. You don't need to read the rest. And there are a lot of queries where you only need to know what's in the header of the file. You need some metadata that's at the beginning. And that's a really big plus. If you just want to extract that metadata, read it, and then carry on, you don't actually have to parse the whole file. So that's a big use case for streaming. So I think there's lots of opportunities. The static analysis algorithms used by streaming and projection can certainly take advantage of each other. We could improve reuse there. I think the stuff we do for projection could actually be used to automate some of that injection of a copy of. I think we can detect a lot of the cases where that's needed and inject it automatically, and I think that's an option we should look at putting in to make more queries streamable. Projection handles variables and streaming doesn't, and there's no reason for that. It's just a limitation in the analysis. I won't talk about functions, but there's problems with both. So that's it. Questions?
What about performance when doing the streaming on efficient XML? Because you say that the parsing is most of the time. Did you do any tests on that?
I'm sorry, the question is?
What about performance when doing streaming on efficient XML, or binary
Oh, efficient XML. Yeah, I mean, it's orthogonal. If we can speed up the parser, then we can get benefits from that. And efficient XML, binary XML might well be one of the ways of doing that. But yes, I think people don't realize the extent to which transformation is dominated by parsing cost in very many cases. And we definitely should be putting more effort into cutting down the parsing cost for a lot of these workloads. And that might well be one of the ways of doing it. Yeah, thanks.
Michael, I would like to know how you think about the following alternative. The projection you describe is driven by the query. So why not let the query author, when parsing the document, let explicitly determine how projection is done? So I'm thinking of a new function, could be called filtered minus doc, with two parameters, a URI and a specification where you say what you want and what you do not want.
Mm. Yeah, there's actually a function that was added to XQuery called unordered, with that sort of motivation in mind, that it's a sort of declarative way of saying I don't care about the order of the results. Of course, no one uses it. And there's one of my first rules with performance is that if you add a knob that people can turn, then only 1% of the user base will ever discover it exists. And so performance features that involve twiddling knobs to improve performance are always a little bit frustrating in that people don't know how to twiddle them. And the existing unordered feature in XQuery is one example of that. Yes, there are things you can do with annotation, and of course with streaming we're doing that as well to an extent. Sorry, have I misunderstood the question?
It seems to me you misunderstood me. I mean, it is so clear, so explicit. For example, I would like to have the possibility to say doc of a URI, but I only want the root element with its attributes as the simplest possible case. So I can imagine very well to think about how to specify. Very simple, for example, you can give qualified names of elements you want to skip and so on. It is very explicit, very clear. I do not understand why you compare this with ordered, unordered. I mean, my experience is I know the documents I'm working with, and I know all the rubbish I'm not at all interested in. I would love to be capable of saying right away, this part I don't want. And I think this is simple.
Yeah, well, I'm hoping one of the things in the sort of conclusions, things we might be able to do, is to improve the analysis on XSL source document, so that we can detect cases with XSL source document where you can detect that this sort of projection is possible and do it automatically. Because, I mean, going back to what I was saying in response to your question, the reason no one uses projection is that it's one of these knobs you can twiddle that most people don't know about. And my aspiration is to find a way of using these technologies in a way that spring into action without you asking for them, just because we're smart enough to know when it's needed.
Okay, thank you very much. Probably we don't have time for any additional questions now, but you can continue after today during the social event, because it's very interesting and very in-depth topic. So thank you again.
Thank you. I'll leave all this here.
All right.
Okay, so we have the last session today in front of us.
Okay. Do you understand me? Because it's all right.
It should be okay, because they will adjust level once you start speaking. And I think it will be a very interesting session delivered by Markus Reichhardt, because you probably heard a lot about HTML5 and 1.1, and one of the things you probably have been reading or listening to have been that there is nothing related to HTML or BTD or XML in HTML5. And if you look at the name of this talk, there is HTML5 and DTD together. So I'm really looking forward to this.
Thank you. Yeah, let's talk about HTML this afternoon. Let's first take a look back on how XML came to be. And this is a very brief historic rundown of it. If you remember, 20 years ago, almost XML 1.0 was specified at the same time as WebSGML was specified. And the goal was to simplify SGML, which was considered too complex. And at the same time, SGML was enlarged to allow DTD-less documents. Before SGML, traditional SGML needed a DTD document type. So this Venn diagram is supposed to depict the situation back then. And well, we now have a situation like this. XML is a proper subset of SGML. So that goes very far because XML has been, well, per definition, specified to be in a subset of SGML back then. These are the features that were left out from XML and were considered obsolete or something. I will shortly run it down and then we'll go on to some topic in depth. First of all, markup minimization, like a tag omission. That's a big one for parsing HTML. Then we have a little bit more emphasis on entity and notation techniques, something that XML has, but it is not very often used with XML. Plus custom wiki syntaxes that gives the root to a parse markdown. If you're familiar with it, it is a very familiar wiki syntax that's used often in the web context, plus a number of other things. Time permitting, I will also would like to speak about SGML link. This is an obscure feature of SGML even in its heyday, but we are going to use it to produce web documents later on, time permitting. So we are talking about HTML. HTML5 or 5.1 is not a proper profile of HTML. That's what the definition, the specification text itself says about it. Well, it is, I think everybody knows that HTML is not properly aligned with any other markup language, and never was, even back in HTML4 times. We will shortly consider the HTML features that are problematic to parse with SGML, and these are HTML's transparent content concept. It means that an element, the content model of an element inherits, so to speak, the content model of its parent element and also contributes to its parent element's content model. Well, in the proceedings paper, we show that this is not really a problem. It is more a definitorial device, but it's not actually a problem. We come by using SGML content exclusions, which I'll explain later on. Then we have the issue of table content models. Well, in the proceedings paper, I make a point that it is not very well specified, and even the specification text is, of the HTML specification text itself is erroneous. So we are not discussing this in depth here. And then we have a number of trivial issues like lexical issues. These have to do with the various types of name tokens that you have in HTML, like ID, values, names of elements and attributes have slightly different definitions of what allowable characters are, what characters are allowed in them. So for this part, HTML5 is considered a profile of SGML, and the details of why, well, the intricacy, I would have to refer to the full paper of the proceedings paper, because it's a little bit too much details. And I will talk now specifically about HTML features that are not in XML, because of course all of you know XML quite well. And the features not in XML are tag omission and tag inference, empty elements, a short syntax for enumerated attributes, and unquoted attributes and content exceptions. I will first show you how tag omission with HTML works. Now this a valid HTML document, there's nothing wrong about it, and a browser would be perfectly fine to parse it and display it. Question is, how is it parsed by HTML and HTML as well? Well, HTML needs these declarations to parse it. I've included a short explanation here. This double capital letter O means in this context that the HTML element, the head element, and the body element are allowed to have their start and end element tags omitted. And likewise for the P element, which is only permitted to omit its end element tags, but the start element tag has to be there. And we have another notion that is specific to HTML, but didn't find its way into XML, that is content exceptions. If you look at the definition of the P element here, this syntax any without, well, in place of any you could use ordinary content model. The important thing is the minus the thing here. It means that P admits any element except P anywhere. So not only in immediate child content, but as well as in any descendant content of P. So now let's put this minimal DTD to work and see how HTML is able to parse it. So first, HTML by its doc type knows that the document is supposed to start with an HTML element, so it puts it in there if it isn't there already. Next step is the head element is inferred because it's required to be there by the content model of HTML. At this point, HTML encounters the title element and accepts it as child content of the head. HTML then, when it sees the P element, will end the head element because the P element isn't allowed in the head element. And at this point, we are in the HTML content model have completed the head element, so HTML can infer that now the body element has to follow. And, well, then HTML accepts the P element. And at the end of the document, oh, no, not quite yet. First, it infers the end element for P, and then in the next step, at the end of the document, it accepts the end elements for P, for body, and for HTML. I must say I'm feeling a bit silly to explain it to some of you, because some of you might have been around at the HTML time, so who am I to explain it to you if you have even been involved in the creation of HTML. But nevertheless, I think it's something new, unknown to people who, like me, came to markup with XML. So another feature of HTML that is important for HTML parsing is attribute minimization. Well, it's not a very complicated thing. You will have encountered it in HTML tag, these minimized forms of specifying an attribute. And it's not surprising that HTML uses these features because original HTML was, of course, based on HTML. So these are the features that we're going to use for our HTML DTD. Well, let's first see how the HTML 5.1 specification presents its vocabulary to us. It lists all these elements in categories like these. That's supposed to be a Venn diagram where in every bubble there's a set of elements that belongs to that category. And the first thing we do is we are creating entity definitions like this from the respective category. And so we're doing it for all these categories that are listed, and so on. And well, this is the result at this point. It's a pretty straightforward transcription of these memberships into parameter entity declarations. One thing notably missing from HTML5 is its lack of a definition for block and for block content. Well, if you step back a bit, we have this situation where we have flow and phrasing. These are the main categories of HTML element, where phrasing is inline element, more or less, and flow is anything that can appear in the HTML body. But we do not have a particular category for block-only element. We have to derive it synthetically by really subtracting all those phrasing elements from flow elements. And that's what we are doing. And then we get this entity definition as well. And we are going to need it for our mapping of individual elements. Well, I will make an example for the P element. That's how the HTML5 spec, 5.1 spec specifies the P element. You do not have to read it all through. We will discuss it in detail. First things first, the content element is supposed to be phrasing content, and that translates straightforwardly into an element declaration like this. And now we come to the tag omission rules for P. That's a little bit more complicated. If you, an N element may be omitted if the P element is immediately followed by these elements. And these elements happen to be exactly those that we have subtracted from the flow category in the previous slide. So we can reuse this entity definition, and our complete DTD declaration for the P element looks like this. Well, it makes sense that in a paragraph, in a P, block elements shouldn't happen. And at this point, SGML ends that paragraph and attempts to parse a different way. Okay. So the complete DTD looks like this. It is quite readable on its own because the normative specs of specification text is always included. So I think it is. You can see that it is quite straightforward to read. Okay. Well, there are a little bit more details to take care of. For one, we have a permissive DTD. That is the DTD that doesn't include definitions for all elements of HTML, but only for those that have special parsing rules. Much in the spirit of the mini DTD that we, the four-liner DTD that we declared in the beginning. And there are obviously a number of additional points. One consideration is the lexical parsing rules for names. And this is, the full paper goes to great lengths to come to a definition for these, because we have slightly different definitions for all of these lexical items. Okay. So let's see what we can do with it now that we have this DTD. Well, first we can parse HTML, and I think that is maybe for the XML community something that could be of value to them, because you have now a defined way to get web content into XML as well, without falling back to any heuristic or ad hoc approaches for doing so. And this is, I hope, is of use to somebody, to the markup community. Well, I hope you're a little bit familiar with Unix command line tools. We have this very short document here, and we are going to parse it. There is a command line tool, XMLPrague, and well, this is what it spits out. It is an error because we have misspelled the attribute. It's called reversed rather than reverse. So we are going to fix it here. I hope you can follow this with the set command here. Well, if not, well, I'm just changing the reverse into reverse like it should be. And now the result, we parse again, and we see that in fact it parses and actually is output in a canonical form with all text, with all omitted text completed. And that would be, of course, possible using XML as well. And the same thing can, of course, can be done with the venerable SP reference implementation of SGML, OpenSP, it's now called like that. Well, of course, it's the point of having a DTD so that SGML tools can make use of it. And this just an assurance that it's indeed the case. Well, OpenSP puts it out in uppercase letter. It's a little bit ugly, but nevertheless, it's the same thing. Well, another application is, I hope you can see it, the WOT working group. Well, those who do who do a lot of work in the HTML space actually have picked up flaws that we found in, well, that are discussed in the paper, and so that already has contributed to ever so slightly improvement of the specification text. And in the paper, I also make a point that a certain rule that happened in the addition from going to the HTML 5.0 to the 5.1 text is erratic, in my opinion. Well, you can prove this using really run-of-the-mill tools by using DTME and the DTD, and just run, for example, OpenSP tools against it, and it will tell you that the content model is ambiguous. The particular problem in question is that, well, the data list element, well, it has a content model which allows phrasing content on the left-hand side or scripting content on the right-hand side as operands of the union of the alternation operator here. And this, the template element is contained in both of these categories, in both phrasing and in scripting. So that's not supposed, that's ambiguous in SGML, and it would be ambiguous in XML as well, because SGML appeals to the same notion of an automaton, a Glushkov construction, just as SGML. Of course, HTML is not bound to this particular definition of ambiguousness, but I think because it's semantic, it doesn't make sense at all that you would have a template element in here. Is just an error that could be fixed. Okay. Well, for what it's worth, have also put together a list of issues that I found with a modern usage of SGML, and I hope, well, if there's interest, then I would like to. Well, it has been suggested to me that maybe after 20 years it's time for a new ISO, for a new SGML revision, but well, I'm okay with SGML as it is, so I'm not pushing for it too hard. But if there's interest, I will be cooperating with it. So I want to now introduce my little SGML parser and SGML system. Well, comparably speaking, SGML is quite a considerable effort to implement, It is a different kind of beast than XML for sure. I want to show you how it's being used for practical web application work. Well, HTML, like XML, deals with plain static files. Let's look at HTML.js has a notion of a template. That is something that I hope to explain, time permitting, a little bit in detail, but at a high-level view, this is what a template file looks like. In this particular case, this file is supposed to construct an RSS feed from a blog document. I hope you are familiar with RSS and blogs. Well, I think it's not too difficult. So what's in there in HTML that supports this? First, you have entity metadata. You have, as a feature of HTML, you have an HTML or markup-aware injection-free transclusion, which is an important feature to have on the web, of course. And you have a notion of filtering and templating. It's not as powerful as XLST is, say. For example, you can't do joins, but nevertheless, it's an automaton-driven way. It is, well, in terms of power, it is a little bit like CSS, or rather CSS3, but not CSS4, because CSS4 has features like the parent selector that wouldn't be possible to represent using HTML-link. Okay, let's see it. HTML.js, as the name implies, is written in JavaScript, and this gives rise to different kinds of running it. For one, we could do content aggregation on the server side like this and serve to the client a plain HTML file. Well, in this scenario, it is envisioned that first a cold page load against the server is rendered server side and in many cases will be cached and then is transferred to the browser. And the subsequent page load could then be aggregated in the browser all on its own. And the system is supposed to work completely transparent. That is, it's producing exactly the same result on the server as on the client. So it's kind of a drop-in replacement. And there are a couple of other usage scenarios for this as well, but these are the main ones. Yes, I would like to point out, even in the case where HTML is processed on the browser, you can run it against a static web server and it would be working okay, but the system can benefit additionally from HTTP2 push because it can take advantage of entity declarations, which are exactly the same as HTTP entity declarations. What will happen then is that you request a part of a document and the web server is able to push the rest from which it knows that these resources will be needed shortly after, reducing server round-trip time. I will shortly, well, it's not all there is with HTML.js. Obviously, it has a number of integration like SQL access, file system. It has, of course, HTTP client access, and well, actually, it also has a specific support for Sparkle protocol querying in a quite straightforward way. And this is what's being on offer here. We have command line tools, and we have an implementation for Node.js, which is not a standalone implementation, but is used as an embedded HTML processing system, and a standalone backend for Apache HTTP. And the latter one is then well integrated into shared hosting and all the ecosystem around Apache. Well, I don't want to gloss over this. I will skip these slides a little bit. Let's see it a little bit in action. Well, I've told you about templates. Now I want to show you the template I used to create this very slideshow that you're seeing right now. Well, the idea is that you have a template file and which has all the intricacies of formatting a slideshow into an HTML slideshow ready for the web, and an actual slide client file that only contains the actual content of the slideshow. Let's look at this content. Well, this demo is written with reveal.js. You have seen it this morning as well in another presentation, and I'm using it as well. This is what a reveal.js expects as input. It is a very straightforward markdown formatted text. So important is these ruler lines, the 3 hyphens in the middle of the text. These separate slides from one another. So, well, to begin with, we have a very basic HTML file that just pulls in the demo slides markdown document into the main, the master file. And then we need to get markdown parsing out of the way. As I told you, HTML has short ref limiters as a means to express wiki syntaxes like markdown. And this is a little bit the heavy syntax to make it happen. Well, for anyone who's interested, we need to configure delimiters that are recognized in HTML data in addition to the angle brackets and ampersands that are usually recognized by XML and HTML. And then we just map these delimiters, in particular element context, to replacement text. That's how wiki syntax works with HTML. Okay, Reveal.js needs HTML that looks like this. It wants to have these section wrappers around slides. So we need to somehow create those section wrappers from our rulers, from our horizontal lines. So one way to do that is to use a DTD for it. And this is actually a point, well, we have in the first part, we talked a lot about validation and parsing, but DTD declarations HTML have actually a little bit wider role than just for validation. What we're here doing is we declare the content of the body element like this, means a section element followed by, well, a horizontal ruler followed by a section element, and this ladder group repeating as many times as wanted. And this will then make HTML generate an initial section element before, as the first thing in the body content. And the next declaration is that if we encounter the HR element, then it will generate a new section element, right? I hope you can follow it. That's how it's a simple means to generate, well, this, well, here it is shown with markup or equivalency with HTML. Okay, well, we have a couple techniques shown here as well. And, well, we have a templating mechanism, but that I won't explain it that well. I don't have time left to explain it, but I think I hope you can see that a DTD or HTML is a very practical way to deal with HTML content. If we now look at the final slides template that we created, it contains these additional tweaks and quirks that we have to deal with in HTML content all the time. So the idea being is that you really can separate the content file from a master HTML file that contains all the quirks that you need to do for modern responsive web apps. Thank you.
So I think you have made SGML great again. So do you have any questions?
I have one. I think SGML Guru find a new master now.
Sorry?
I think SGML Guru find a new master now. You're using SGML everywhere.
Okay. Yeah. Well, I'm not sure. Maybe there's. I've seen some people a little bit older and know probably a lot more of HTML than me, but.
I have a question. You didn't pass CSS with SGML.
Yeah, right.
You didn't pass CSS with SGML, did you?
Sorry?
You didn't pass CSS with SGML parser.
No.
Why?
Well, I think Norman Walsh had a session last year about parsing JSON with SGML. And it's an interesting, and there are a lot of SGML hacks that you can do, but I want to make sure we're using it really for an actual production job. And we're using it for quite practical web publishing. It's not a curiosity that we're using for a kind of, well, we're actually using it as a production tool for us.
And there is a question over there.
Maybe you told it, but how do you present the enumerable attributes in the DTD?
Sorry.
Could you repeat it a little bit more louder?
The enumerable attributes, how do you present them in the DTD?
I'm sorry, I didn't understand.
The enumerable attributes, repeatable attributes,
yes,
or data attributes, how do you present them in the DTD?
Repeatable?
Not an enumeration of attributes.
Oh.
If I heard it correctly.
That's not difficult. I hope we have an example. Well, that is a very simple thing. I could draw it. I think we have no example here. Yeah, well, let me sorry. How do we change that to? Yeah. I will show you on my.
Sorry, I started developer tools.
Yeah, okay. Yes, do it. Let's look at. Well, we have a pretty comprehensive reference for SGML here online, and I hope that, yeah, this is the syntax for enumerated attributes. So you just, well, specify them like that. For this element, for this attribute, attribute, you have the possible values, well, 1, well, 2, well, 3. That's how you specify. Does that answer it?
I meant the data attributes, all these attributes starting with data in HTML5. Yeah. How do we present them? How do we present their names in the DTD?
Yes. You mean custom attributes?
Yes.
Right. Well, either you can go a permissive route where you by default accept anything, unless it violates the declaration that you have. Or you can declare them in a custom DTD, in a subset, an internal subset of the document. There you can, of course, declare your attribute data, X data, whatever you like, and same with custom elements. So either you accept the SGML's behavior that anything goes as long as it doesn't violate an explicitly specified rule, or you declare it. Of course, it cannot, HTML cannot magically parse or understand that you want to have the data, these particular rules that HTML has like the data attributes. Of course not. You have to declare it usually.
And we have still time for last one question from Romain.
Yeah, have you done any research with a corpus of popular web pages to try to estimate the coverage in which your DTD-based parser provides the same results as a spec-compliant HTML parser?
Yeah, not yet. Well, we tried to. There is actually web test case suite, the web platform test, but it is really unclear to me how it is aligned to the published HTML specification. It is on GitHub, and it changes all the time. And most of the test cases are of the trivial sort. They violate attribute details and attributes that have to be there or that don't have to be there in combination with a certain other attribute. These are not the test case I was hoping for. What we did, I can say the system is able to parse the HTML specification text itself. And that's a pretty big document. It weighs in at about 15 megabytes or so. But actually, I hope that a community would evolve around this initiative to come up with a new DTD, and then, well, I do not want to do it all on my own.
Thank you.
Okay, thank you very much.
Thank you.
So sessions for today are over, but we are not finished yet because there is a social event in the evening and a demo jam. So if you have been there before, the location for dinner is the same as in the past years. But if you don't recall it, or if you are here for the first time, if you will take the schedule from your badge, on the back side there is address of the location for a social dinner, a map and some instructions. So hopefully by following those instructions, we will meet like in 1.5 hours at the location for social dinner and for the demo jam. Norm, do you still have one free slot, or? So there is last free slot for demo jam, so you should be quick. Okay, so thank you very much for attending. I hope you have enjoyed this second day. Is there any? Yeah, I can do that. And what's the Twitter? What is the Twitter? And Google Maps? I'm just kidding. Okay, would you like to say something? Or? So I think we are finished with sessions for today. We will see each other soon, and yeah. My Twitter account from here, but I will make it from my laptop.
Yeah, I got a lunch.
It's a really nice thing. Oh, hang on, it's been sitting there with
What?
It's unplugged.
Yes.